where there's actually high-speed connection born, right? I mean, we talk about
anybody trying to get into the client server option
to their face, right, or some form of tablet, right, streaming content, right, 24/7. Okay, so this is the reason why this remains as a core course, because you cannot really go through a computing field or engineering field without understanding what networks are, right? The client server model has been around for decades, right? The evolution of that has taken place, right? Because we've gone into sort of the cloud sort of platform and the cloud infrastructure, but really that's still sort of in essence an evolution of the client server architectures, right? Our usage of data model has really changed. We used to only pull information. Now data is pushed to us. In fact, now data is pushed to us in a very synchronous manner, right? You're able to get the same login profiles on different hardwares because all your data is actually stored on the cloud, right? Wireless, right, as a form of last mile data transmission is only more prevalent now than it was before. Can you imagine that if I say now all of these devices that you use, your cell phones, your laptops, your tablets, if I say this, you can only use them if they're connected by a wire, which means that you have to have a cable tethered to it all the time. Would that change your usage model?
For sure.
Exactly. I mean, can you imagine that every time you want to do a tablet viewing, right, you have to pull a cable to it? So all of this really puts us at the forefront, right, as to why we continue, right, the study of data communications. Okay, so before I give you the break, and then we'll go more into this, I'm just trying to lay out sort of the reason why we continue to do this. Has anybody heard of something called 5G networks? Yes. Okay. I mean, there's a lot of talk on the media, right? 5G. Okay. And so 5G really refers to the fifth generation cellular networks, right? So most of us are on 4G right now, right? Most of us are on 4G because 4G really, right, references LTE. Okay. So I want to, yes, it's not in Canada yet. There is a trial going on now, I believe, on the East Coast. There is a lot of questions on who the infrastructure provider can be and cannot be, right? So that's sort of debated quite hotly in the media. But let's just forget about the politics around it, but just look at sort of the data communications portion of it. Okay, so we talked about 4G and it's LTE. Who's on LTE? Who's not on LTE, I should say? So if you don't know, every time when you turn on your cell phone, right, you might see the word LTE at the top, right? So if you're on a fourth generation modern day cell phone in the last couple of years, right, 4G, LTE, so on and so forth, okay? So what I mean is cellular data that you actually use. So if you're on 4G and you're on LTE, have you ever, for any moments, thought for a while that maybe this LTE 4G system is insufficient in terms of the data rates and the latency experience? Or is it, in general, really very much adequate for everything that you do, like when you're texting, when you're watching Netflix streaming in 4K, when you are trying to do an online purchase, when you're trying to access cloud-based data? Yeah, exactly. The general sense, right, is that LTE, right, that came about in the last 3 or 4 years, very much, in fact, suffices the needs even of modern day users like ourselves. We can really do very sort of lag-free type of high-quality video streaming. We can do real-time data services. We can chat. We can talk, right? In fact, all the phone calls that you make are going through what was known as a voice over IP. So why do we need 5G? In fact, if you look at all the discussions that's going on around 5G, right? Is it just increased bandwidth? So yes, Jason, you're absolutely correct, right? 5G allows to get even higher data rates. What type of considerations? Allow more connected devices? Yes. Sure. So 2G is still around, so you know, Jae Yong, right? So what happens is that your phone will continue, right? If you don't get a 4G connection, will downgrade to a 3G, and then in some places it will downgrade to a 2G. right? 2G is essentially analog. Profit is obviously always important, okay? But why 5G? What is the biggest change in 5G? It's actually not the throughput. So the throughput we expect, right? So yes, there'll be an increased data rates, right? That we expect with every sort of generational releases of new cellular standards. But actually, the biggest change, right, to the 5G network is what we call ultra low latency. What does that mean, and why do we need that? Yes, all of that too, Jay Young, right? Like efficiency, increased data rates. That's expected because there's an evolutional sort of a change, right, in terms of a release of technology. But why do we care about ultra low latency? And in fact, if you have been reading around the news, you will notice that 5G is actually very much, in most cases, referred to as a national security infrastructure. In fact, if you are late to deploy 5G, right, it has consequences at the national level and not just at the user level that you assume that, you know what, I have a 5G phone or not a 5G phone. But 5G network is touted, right, obviously to have even national security considerations. Why? And what are we expected to do with these networks? We'll get through this question and then we'll give everybody a break. Anyone? What do you think is the main push for even higher data rates? If 4G suffices for all the needs that we do now as a human, right? What do you think 5G and the implications of 5G will be? And what is the big driver of data usage?
You get more real-time response, I guess.
Yes, but why do we need that? Yeah, ultra low latency. So has anybody seen this term? IoT, right? Internet of Things. What is that? Okay, effectively, right? If you start to think, and this is just a foray as to why data communications becomes even more important for the push for higher data rates and very, very low latency. I'll give you a very simple example. Okay, the Internet of Things, right, will be the next secure data. Yeah, smart. Yeah, so it is connected devices, but the Internet of Things, right, it is a very loose definition whereby now every single device will communicate with each other. That opens up the entire new form of communication known as M2M communication, machine to machine. So data in most cases that are being used now is actually being triggered, right, or pulled by humans. So humans are the ones that are really sort of moving data around, and because we want to communicate. But can you imagine if every device or every appliance starts to communicate with each other? Who has a light bulb that you can actually now adjust on an app, like the colors, the hues, the brightness? Exactly. So Lacey is right there now with the light bulb. Okay, that's an Internet of Things example. Now, that's an Internet of Things example. Can you imagine now that if every light bulb in your home, so usually not all of your light bulbs are now connected, but let's assume that every light bulb is connected. Now, let's just not assume that every light bulb is connected to your app, but let's assume that every light bulb can communicate with each other because they want to adjust their brightness at the same time. They want to adjust their white balance at the same time. Okay, so the reason why 5G networks are such of great concern is we are expecting an explosive growth in data usage through machine-to-machine communication, M2M. Okay, what that means is this, right? So if you've seen things like autonomous vehicles, right? So they're now roughly at level 3.5, level 4 autonomous driving, which means that it can sort of drive by itself. But can we imagine a world now where, in fact, every light bulb, right, traffic light, right, every road sign, every sort of a car is talking to each other. In fact, as you drive down the streets, right, the autonomous driving is not just based on the cameras and the sensors on the car anymore, but there's based also, in addition, right, the communication between your car and the cars beside you, your car and the traffic light in front of you, and maybe 2 traffic lights down the road, right? Can you imagine that type of communication that goes on, right? And it's completely driven by machines, right? Trying to obviously achieve safe driving, right? In a fully autonomous level 5 world. Think for that for a minute, okay? The amount of data that will be generated, right? And of course, what I did bring up was this: 5G's purpose was actually to produce what we call a ultra low latency network. And you might think, what does that mean? Well, it means the entire core network, the backbones of the network, have to support this ultra low latency. Because if you think about it, right, if the traffic light is communicating with your car, any split second delay could result in an unsafe driving condition, which means what we really want, right, is we want data to have latencies of even down to the microseconds in black. So this is greater and beyond, right, from a criticality point of view. Who's a gamer here? Like, who plays online gaming, first-person shooters? And you know that there's a very common term called ping time, right? Obviously, if the coordinates of your enemies get to you too late, right, then obviously you run into issues with it, right? Because you might sacrifice a life or something like that. But if you have all of these machines, right, communicating with each other in autonomous driving model, right, that could mean life or death situation. Okay, so this whole 5G, yes, increase in data rates, yes, right, much more users on it, much more machines, but the core to this whole revamp of the network, right, is called ultra low latency. And in fact, right, what happens is that it is so critical that it's actually deemed a national security concern. Okay, because of the services, the type of applications that will run on it. Okay, the last example I'll give, and I'll give you guys a break, right, is imagine when you get up in the morning. I believe, Chantel, you like to drink coffee. I'm making it up, but I suppose that she does. Okay, but Chantel is very particular with her coffee, right? She wants to brew her coffee every morning, right? But she wants to drink it at an optimal 93 degrees Celsius. Right. She doesn't want still coffee. It's got to be like, brewed fresh, with the minimum of oxidation that goes on, and it's got to come off the cup, right, at 93 degrees, right? So by the time she gets to sip it, is roughly at a very comfortable 80 degrees, exactly. But just so you know, Chantal, I love very bright coffees, so I like them really, really acidic. But we can talk about that later. But not only that, let's assume that Chantal likes, her coffee optimally at 80 degrees, but she also likes to eat toast. But she doesn't want toast that's burnt. She doesn't want toast that is under toasted. But she asks for an optimal piece of toast, which means just off the toaster, crispy on the outside and moist on the inside. Right? So that's the optimal toast that Chantal likes. But she has another requirement. She says this: I want my coffee to be done at the same time as the toast, which means by the time the coffee has finished brewing, right, which usually takes about 4 minutes or so, right, she wants her toast available at the same time, toasted to the optimal level. And as a human, she's incapable of achieving that level of precision. Right, Chantal? I mean, sometimes your coffee is brewed 2 minutes early, and then your toast is, a minute behind, or sometimes your toast, is done early, and so on and so forth. But can you imagine if her coffee brewer can communicate with the toaster? And so at the end of the day, she says this, right? The class starts at 9 o'clock. I want my toast and coffee ready optimally both at 8:30. Right. So now all of a sudden, right, your toaster communicates with your coffee machine. Your coffee machine communicates, right, with your alarm clock, right. Yes, you want them to be done at the same time. Okay, and that's a level of finacity, right, and optimization you can do to your life, because now all of a sudden, right, you're not in the picture of actually having to create that. You only have to say this: I want a perfect cup of coffee and a perfect cup of toast ready, right, all at the same time, 15 minutes after I wake up. So all of a sudden, right, your toaster communicates with the coffee machine communicates with the alarm clock, and yada yada, right? The world is fully connected, connects to your fridge, try to make sure that you have the right toast. That's the world of IoT, and that's not even something that we are sort of writing up, as some kind of a science fiction story, right? This is reality in a few years. In fact, some of these components already exist. Okay, so I want to give you guys a break. Okay, are there any questions in sort of the high level overview and hopefully some motivation as to why we're doing this? The end date is this, right? Is that we want high throughput, or I should say high data rate, and we want low latency. And this is what this course, right, data communications, is going to drive us towards, right? Because this is where we want to attain and figure out how can we, in the networks that evolve going forward, achieve even higher data rates and even lower latency. And this is where the focus of the course is. Okay? Any questions? So we'll take a break here, okay? So I'll give you guys a slightly longer break. It's the first break that we have. We'll take a 9-minute break, and then we'll resume, right? So if I write this here, we'll resume at 10:20. Oops. So break, right? Resume 10:20. Okay? See you guys in a bit.
Sounds good.
온라인으로 올려주잖아. 이러면 택각 그 시간마다
Is everybody back? So Chantel, do you have your coffee at 93 degrees brewed? Yeah, shall we do that? Usually I don't initiate, but let's do that just because right? Is everybody back? So it's interesting. I stopped the poll actually, but it's interesting that somebody is not back but is able to click no. That's okay. It's just it's a non-consequential poll. Okay, so are there any questions? So I believe somebody else also added on to the class that was not here before. I'm trying to figure out who that might be. Was it you, Iris? Was it Iris Lau? Are you sort of just getting onto the class? Did you miss the sort of the introduction to everybody at the in the beginning of the class? Okay, so let's get started. Are there any questions before I spend sort of and go through this deck of slides here?
Not yet, no.
Okay, good. Is the pace going on okay, Rana? Like, is it?
Yeah, I think it's okay.
Okay,
For
good.
me,
Okay.
least, yeah.
Yeah. No, I just want to make sure that the quality is okay and everything else, and everybody's sort of following along. Okay. Yeah. Okay. So the next thing I want to do is very formally go through what this course is. To start, right, I just want to give you a quick idea of who I am and what I do. My name is Jian. You probably know that by now. I actually run an option in the CST program. I had what's called the AI machine learning option. So that's a relatively new option. It's been this is my third year offering it, and so far it's been a very exciting and fun option for me to run. And I'm very happy of the students that are doing the option. Just to give you some highlights of the students, the first two. So I'm in my third set right now, but the first two sets of the option that I ran in both years, the valedictorian has came out from the AI and machine learning option. And that is really exciting because it's a back-to-back valedictorian award, and it's not a department award; it's an institute award, right? So you are selected to be the valedictorian, to be sort of the highlight of the graduating class, right, at BCIT, and your goal is to sort of inspire and motivate, right? So that's been really good. My office, unfortunately, that you don't get to go to anymore. I did go back to my office about a month ago, and it was completely quiet, and it feels like the whole entire building is deserted. But it's in SW2, which is in Burnaby, 125. Okay. Here, this is how you will contact me if you do need to do so. Email. Okay, in particular because we're moved also online, it's very rare that you will actually come face to face in person and meet me. Okay, but when you send me an email, I ask for a couple of things, right? Send it only to my official BCIT email. Don't send it to my aliases like chuang151. Just send my first name _ last name at bcit.ca. Okay, so anything that you have pertaining to the course, right? Email me. Okay. At times, if you're trying to ask sort of a more technical question, I might say, because we're online and you don't get to come to my office hours, I'll say, okay, let's take this off on a bongo session, and I can create a bongo session in a couple of in minutes, really. right? In fact, in seconds if I want to. And I can have a bongo session so we can actually have the scratch board and we can have some interactive sort of discussion, on the problems that you might have. Okay, but the way to contact me and initiate any sort of further discussion, right, is through email. Now, I'll also give you my phone number. And the chances that you will find me at my desk when you call me is close to zero now, because I'm not in my office. But the reason I give you is that let's assume that you have an urgent matter you want to let me know of, but you don't have access to your email at that moment in time, but you do have access to a phone. Well, you can call me and leave me a voicemail. Right. What it does is it automatically sends and attaches that voicemail, right, to my email account. So in fact, it is also through email. It's just that if you're unable to type up an email at that moment in time, you don't have any data service, you can send me a voicemail and then automatically it's attached as an attachment in my email. Okay, so that's the way to contact me. Do not come to my office because, in fact, the buildings, I believe, is actually locked as well. So you shouldn't be going to the campus without authorization. Okay. Now, one thing that I ask for you to do as well when you email me, and this is really important, I want you to tag your emails in the subject line, which means I want you to put in square brackets, right, Comp 3725. Okay. So I'm currently teaching 4 different courses right now. So by tagging your subject, my entire inbox is actually filtered. So students that I'm teaching for the current term have the highest priority, right? So what this does is allows all of your emails to get to me and be at the top of my inbox because it's actually filtered that way, okay? So tag it. The other things that I want you to do within the body too is that please write your legal name as in your registered class name. Don't use your preferred name now because I really don't know who you are. And don't let me rely on your emails to try to figure out who you are, because I've even gotten emails from like darthvader@gmail.com. I've gotten all kinds of email addresses, and to assume that I know who you are based on your email alias, that's a stretch. Okay, so please give me your full name, and if you can, your A00 number, because sometimes there might be students with very similar names. Okay, and because at least for data communications at 3725 this term, right, just tell me whether you're from the morning or the afternoon set, so AM or PM. Is that clear? I like to be able to put a face to the emails that I actually respond. It gets a lot more difficult now because we're completely online, but just so there's a reference point for me as to who's asking this question, right? And I can pull context as to what may have been asked in the past, right, in relation to your questions. Okay, so in a short elaboration, right? Email me, right, for anything that you want to question. We might get on a bongo session if necessary. Okay, but please tag in the subject line the course number, and in the body include your name, your ID, and then obviously which set you're actually from. Okay, so that's set up. I have no idea. So I am not as social media savvy as you think I am. In fact, I have really almost no social media presence. That's, you're asking the wrong person. I think you might be better off asking your classmates on that. Okay, Chantel? Okay, just a little bit about myself, right? I've been in school for quite actually a long time, mostly trained here in BC. I did my bachelor's, it was in electrical engineering, where I started with what's known as the computer engineering option at UBC. That was my first sort of post-secondary education. And then I went and did my master's actually in Cornell in the United States. So that's actually up in upstate New York. I spent about 10 years in New York working at a company called Bell Labs after I got my master's. I don't know if you guys ever heard of the company called Bell Labs. It was once in its high and heydays one of the most preeminent research institutes in the world. Many things that you use today were all invented at Bell Labs, right? So the lasers, the transistors, microwaves, even the C language, and so on and so forth, right? So that was where I spent about 8 years of my life, and then I left New York and came back to Vancouver again. And then I continued on with my PhD, and I did my PhD actually in LTE systems, in terms of a cellular aspect. But I continued my with the same advisor I had actually for my bachelor's back at UBC. Okay. From a work sort of perspective, I've done quite a lot of sort of co-op terms. So my first real job in the industry was actually a repair engineer in a company called Acer Computers at that time. What was I repairing? I was repairing something that you guys may have never even seen actually. It's called a CD-ROM. Does anybody know what a CD-ROM is?
I do.
Yeah, because it's essentially obsolete now. Most media in those days was especially when you're buying software were sort of given to you not as a download, but it's on a piece of plastic, right? And it's called a CD. But in any case, I was the factory built CD-ROMs. To give it a context, right? It was building what we call 8 times CD-ROM, 8 times. But the interesting thing is this is a factory that runs 24/7, 3 shifts at a time. I was not on the production line, but I was on the sidelines of the production line. And my job at that time was to understand and improve what we call production yield rates. So as you can imagine, the facility produces hundreds of thousands of CD-ROMs continuously, 7/24. And essentially they're all produced the same, and then as they get through QA and all that stuff, right, they get put on a front plate, and the front plate determines who the customer is. So you might get a slight shade of gray that is for this particular company, a slight shade of beige that is for IBM, a slight shade of beige for Compaq, or HP. So they're essentially all the same innards, but the front plate that gets put on really determines, which brand it will be sold under. But in any case, my goal was to increase the yield rate. So for every 100 CD-ROMs that are produced, the goal is to achieve roughly 95% yield rate, which means only 5 will fail QA. But we really want to get it up to about 96, 97, 98%. Right, and my goal was to determine, based on all the ones that failed the initial production QA, what the issue was, and it would be surprised. Sometimes it's human errors. Those days, a lot of the components were still attached minimally by humans, right? There could be component issues, right? And we did actually run into a laser diode issue as part of a whole batch, right? But I was there about 4 months, working in the factory. On the sidelines, trying to sort of improve yield rates. Then my second co-op term actually was with a company here locally called Canadian Airlines, which again, unfortunately, no longer exists because it was bought out by Air Canada. So yes, I used to work at the airport. As you drive into sort of Richmond, you'll see that there's a hangar. I used to be on the top floor of that hangar. My job was an avionics engineer. So I was hired to do precisely one thing. Flight data recorder analysis. So that's very commonly known as what's called the black box. So maybe you guys are not aware, the flight data recorders are actually pulled from aircrafts more often than you would assume, right? Anybody know why? Why do we pull black boxes off an aircraft? So a lot of times when you hear it is when there's a catastrophe, right? Where there's some incidences that happen to the aircrafts, and then they analyze the black box to see what went wrong. But more often than not, actually, the flight data recorder is actually pulled quite often. Why? Exactly. It's not just for maintenance, but it's what we call preventative maintenance. So every time an aircraft actually lands at YVR, and about an hour as it approaches YVR, the pilot and the engineers on board actually radios in some of the issues that they encountered during the flight. So it could be things like, I had an extremely difficult, hard landing. I had difficulties in some stiffness in the rudder. I felt that there was excessive vibration in one of the engines, and so on and so forth. So most times when as they approach into YVR, they will be on ground for about a couple of hours. So they radio in all the issues ahead of time, and some of the issues that require us to actually pull the flight data recorder. And what we're looking for are patterns in the data points, right? To see if we can sort of have an insight to sort of pending failures. Right, so they're not catastrophic, but they allow us to do and be ahead of it, right? To do some kind of preventative maintenance. Okay, so that's what I did for about 4 months. The big thing then, though, is that it was a very boring job to try to look at data from that perspective. And in fact, I mean, I said that we do it more often now, but it's still right. It's like once a week or something like that. So my other job was actually the deployment of real-time video on demand on a 747 aircraft, 747-400 aircraft. So those are the double-decker aircraft that you may have seen. And that was really quite fun for me. So the first sort of video on demand system on an aircraft, it took almost $2 million to retrofit about 400 seats. But during those days, all of the video playback was coming off hard drives. And the room that was holding all of these hard drives, because you obviously, when you go in an aircraft, you have all of these passengers that are pausing and playing the videos. I don't know if you've seen people doing that. They just do it for fun because they're really bored. That is tremendous strain and stress, actually, and wear and tear on the hard drive. So every time an aircraft lands, right, we essentially, have a team of technicians that goes up and pulls off hard disks because they're filled. Because of one person sitting there and pausing and playing right throughout the entire, 15-hour flight or something like that. And then I also did another, upon graduation from my bachelor's, I also worked locally here at a company called DataWest. I don't believe it's called DataWest anymore. It's who banks with a credit union? Does anybody here bank with a credit union? So not your Royal Banks or your TD, not the big three banks, but anybody here banks with a credit union like Van City at all here? Nobody? But DataWest is a company that simply does one thing. It's called TP, transaction processing. All of the financial transactions for all of the credit unions in BC actually is handled by this company called DataWest. The facility is owned by the credit unions. It's actually in the basement of a building that looks like a red building, like a red brick building, right beside the Burrard Bridge. So if you ever drive by on Burrard Bridge and you see this red building with bricks on the outside, and it's got a globe on the top, that's where the company is based. I worked in the basement of that building for close to a year. We developed the first Java-based online banking system. So all of the online banking systems for all the credit unions, they have the same backend, only the skin is different. And we were the first to deploy a online banking solution entirely using Java. And Java at that point in time, when I was doing that, was still owned by Sun Microsystems. And we were actually quite celebrated on the media for being able to sort of do the cross-platform development, on using Java, right, for online banking. My favorite language. So it's evolved over time, not as being my favorite, but it's an evolution of what I do. A few years ago, the language I use most widely is actually called MATLAB. I don't know if you guys have ever heard of it. It's an engineering type of a language. But these days, the language I use the most is actually Python. Right, I use MATLAB a lot, but now I use actually Python because of machine learning. Okay. And then I went on to good to know. So then yes, we do. I do quite a bit of TensorFlow as well. Anyways, so then I went to the States. I finished my Cornell degree, and then I went to work for a company called AOL Technologies. I don't know if you guys ever heard about that, but if you've ever heard of the slogan "You've got mail," that's AOL. So I was hired not to do sort of the dial-up part of the AOL. I was hired to actually at that time to determine and compute capacities in a 3G cellular system. So the idea was that data to a cell phone was a novelty at that time. Right, you guys use it for granted now because of LTE systems and obviously the compute powers of all these modern day cell phones. But you got to look back, a few decades. where I was doing this type of work. And the idea very simply was this: can a 3G cellular system support the type of data usage as an individual would on a dial-up system? Simply was that. The person I worked with at that time at OL was it was an individual by the name of Mario Vecchi. He is known as the father of cable modems. So he and his team would obviously the first to deploy cable modems. So cable modems is what you sort of get when you have a service with Shaw, the likes of Shaw and Bell. Telus is now on fiber optic networks, right, and so on and so forth. But anyways, he was an amazing guy and guided me quite well when I was doing my sort of work term there. Right, and then thereafter, when I graduated, I spent I spent about 6 years at Bell Labs working on 3G systems. And then I left Bell Labs and came back to finish up my PhD. And I have been at sort of BCIT for about 7 years now, I believe. And Datacom is a course I've always taught since I was actually hired to teach the Datacom course, and then I've stayed on ever since. Okay, so if you wonder how I spent the last 20 plus years of my life, that's how the progression went. Okay. So that's me, and that's why I take a lot of I don't know what the right word is. A lot of I'm really I take a lot of pride in actually teaching Datacom and networking, because I truly like it a lot. Okay. So a bit about the course in itself, right? There are 2 offerings this summer, back to back. Right, so you guys belong to 64129. That's the CRN of the course, right? 9 to 1. Okay, this course for this term will be conducted online entirely, right, until further notice. So I say until further notice because there are talks that there is a potential. Okay, and this is we'll wait for the directives from the public health, right? That might be some easing allowed, right? Maybe after June, so maybe into July. So the course goes all the way through to July 18th, right? So I'm saying that it's after, so you assume that it's always online. What do we want to do in this course, right? I've already given you some of the sort of modern day applications of why we want to study. So I should say this, any questions on this? You should attend the set you're registered to, because Bongo automatically takes attendance, right? And I'll allow that to happen. So I don't want you to be jumping between sets. So you should really try to make every effort to attend the set you're registered to. Okay. So I've already given you sort of the very high-level applications in terms of current as well as going forward, right? So the current, way of us doing this, right? Your video streaming, your e-learning, like Bongo, for example, real-time services, or what we call it, right? Are getting more and more in the sense that we require more and more data rates, right? Because what we stream now, 4K videos, 8K videos, the entire Summer Olympic Games was to be broadcast in 8K video. Unfortunately, that got pushed back by a year, right? But at the same time, though, even with this requirement for very high data rates, we want very low latency. Just think about that for a minute, right? And I keep coming back to this because essentially, right, if you can understand how to achieve high data rates and lower latency at the same time, you have grasped the gist of this course, right? And that will be the key takeaway, okay? So if we want high data rate, right, and at the same time low latency, are these opposing matrix, or are these matrix that sort of trend in the same direction? So what I mean by that is this. If you want high data rate, is your expectation that low latency will come along with it? Or is low latency in the opposite spectrum of trying to obtain high data rates? What do you think? No, exactly. They're, in fact, opposing, right? So I'll give you an example. If everybody wants more of something, is the expectation that you need to wait longer? Or is the expectation that you have to wait less? Right? If everybody wants more of something, right?
The expectation is to wait longer.
Exactly. The intuition, obviously, is that we will end up having to wait longer. True. So how is it that we're able to say this, right? I want a network that not only gives me a high data rate, But at the same time, I'm also saying that it must give me a lower latency, which means the more that everybody wants something, right, the faster we should get it. I mean, it's a supply and demand issue, right? I mean, look at toilet papers, right? So how is it then if we consider this opposing metric, right, of high throughput, right, or high data rates, and yet at the same time load, how have we been able to accomplish that? Because truthfully, right, we have been able to do that. Does everybody agree? I mean, you guys not only now stream video, but you stream video in 4K, right? But you not only download videos, you actually stream it in real time, which means latency is of concern. So how is it that we have been able to achieve that? Anyone? Buffering, sure. Okay, so compression is one thing for sure. Okay, but compression is now reducing the amount of bits we transmit. It doesn't mean that we're not getting higher data rates. We are getting higher data rates through the system, right? Just so you know, right? Compression is more of a technique that allows more efficient transmission of data, which means that we're transmitting less bits to represent the actual information bits, right? Buffering is a technique, right? Not so much to reduce latency, actually. Buffering, right, is a technique, right, to ensure a smooth playback given the variance of latency that might be encountered in the transmission of data. So you're really saying this, right? Instead of playing back every bit that it arrives at the application on the client side, we're going to buffer up 1 million bits, for example, so that even if there's some glitch in the networks, right, in the data transfer, the end user is sheltered from that experience, meaning that your playback is going to just be smooth. But high data rate doesn't mean sacrificing others' data rate. We want everybody simultaneously to be on high data rate. I mean, if Shankai wants high data rate, does that mean we should drop the data rate of Chantel? I'm sure Chantel will protest, right? I mean, is that what I actually do? Is that what the networks do? Right? If Chantel wants very high data rate, shall I drop Shankai to 0? Right? Think about that, right? Because everybody expects a certain level of quality of service. Everybody wants high data rate at the same time. Everybody wants low latency. Okay. The truth of the matter is, right, we haven't been very efficient in achieving high data rates and low latency. Yes, to the end user, we have attained that. But if you look deeper into the technology that we deploy, that is not actually the case. Because what we have actually achieved through sort of high data rates and low latency for all users is by brute force. And what I mean by that is very simply this. Networks used to operate, right, in the early days at 10 kilobits per second. 10 kilobits per second, right? And then we decided, you know what, that's not sufficient because we have more users that wants to use the network. By brute force, we're going to bump it up to 1 megabits per second. And then we realized that more users want to get onto the network. Then we say, okay, let's just by brute force, right, create 10 megabits per second. And then we went to 100 megabits per second. And then these days, right, we're up to, right, gigabits per second as the standard, right, for any type of data rates coming to end user consumers, right? So your TELUS fiber optic cable brings you 1 gigabits per second. Your cellular LTE systems can get 1 gigabits per second. Your Wi-Fi can go up to 1 gigabits per second, and so on and so forth. And truthfully, you don't use 1 gigabits per second as an individual. But we built the system by brute force so that there is more capacity and there's more data rate, right, than everybody can use. So it's not sustainable, right? Because at some point in time, we're going to plateau. Okay. To give you an idea of what the sort of the core networks run at, right? They run at 100 gigabits per second, and they're going up to 400 gigabits per second. So at some point, we're going to hit 1 trillion bits per second, and then we're going to plateau, right? Or at some other bounds that we have. Okay. So yes, we have been able to, in perception, right, and in reality as well, give the end user a very high data rate and low latency, but we truly haven't done it in a very smart way, right? We've done it really by brute force, by just saying, let's just keep increasing. It's like if I want to let everybody drive on the road system and have less sort of delays, I just keep increasing the number of roads that I have, increase the number of lanes per road, right? But at some point in time, you'll start to see one thing, is that the more roads that you build, right, the more cars will come onto the roads. right? Just like if I say this, you know what, Chantel, you have a network that is only at 100 megabits per second. I'm going to now give you a 1 gigabits per second network. What are you going to do? Instead of watching your videos at 2K, you're going to say, you know what, I'm going to bump it up to 4K. And then I say, you know, I'm going to give you a 10 gigabits per second network, right? And you're going to say, okay, I'm done with 4K. I'm going to move up to 8K. Is that what you do, Chantel? Right? Initially, you might say that, you know what, I only want to have my coffee interact with my toaster, but now I want every device, right, including my television, to interact with my toaster, because the moment I play a certain drama series, I want, you know, my toast to be done, right? So the data requirements that we have is almost insatiable. We can never satisfy that because we are forever forcefully bringing it up. And at some point in time, right, I'm going to say very simply, most of the data that you actually have in storage, the digital data, they're all a one-time use only. So how many of you actually go around and take pictures of every sort of meals that you consume? Like, my assumption is that all of you are social media influencers. True? Is that an overstatement, that all of you are some form of social media influencer? I mean, if you ever sort of look at Jason's Instagram, right? I mean, he takes pictures of every meal, you know, and every item that he consumes for every meal, and he posts them on social media, right? And my question to Jason, right? Jason, so I should say this, right? I'm making this up, right? I don't know anything about Jason. I'm making it up just because he was the last person to comment on the box, right? But in any case, right? How many of you actually go back and review the photos that you take? Probably not all the time. In fact, maybe very rare. So I could, in fact, classify all the data that you have generated, right, to be digital junk. Right? And the question is, why are you holding on to so much digital junk? Right? Only because, you know, hard drives on a per terabyte basis have come down in unit price. But I don't know if you're aware, actually, telcos want you to use more data. True? Because the more that you use, the more profits that they will make. So I'll give you an example, right? Why is it that there's this social influencer campaign, right, to post photos? Well, the more photos you take, the more cellular data you use, the more telcos will make. So if you were wondering what telcos measure the success by, they have metrics like revenue per bit. They want to know how much profits, right, or how much money they're taking in, right, for every bit of data that goes through their network. And the idea, obviously, is the tier one telcos wants the highest revenue per bit, because that means they're the most profitable, right? So just think of the campaign of getting and enticing use to more data. Do you really need to do that, or is it because you have been marketed in a way, right? There's been such successful marketing campaigns to entice you to use more and more and more and more data. Okay. Anyways, I'll rest the case, because that obviously is an individual choice. Okay, so what do we want to do in this course? As I said, right, it's a foray into data communications with networking components to it, right? The first thing that we will do, right, especially in today's lecture, right, is there's a lot of the basic concepts, right, and terminologies that we'll introduce. And we'll do it sort of in a progressive way, where we will sort of talk about them related to datacom, and then to networking, and obviously the different topologies. The topologies are sort of the physical layout of the networks. So that's the first thing that you get out of this course. Okay. My slides are not advancing. Okay. The second thing that we want to be able to do, right, is that I want to be able to give you guys an overview, right, of what's known as the TCP/IP protocol suite. Has anybody heard of TCP/IP, the term? What is that? What is TCP/IP? What is TCP/IP?
It is a protocol used to pack up data and communicate and actually transmit them through devices.
Yes, that's very true. Okay, yes, okay. But why? Because if I tell you that part of this protocol, right, if you look at the protocol stack in TCP/IP, it actually consists of 5 layers. Okay, it starts off with sort of the physical layer, moving on to the data link layer, to the network layer, and then the transport layer, and then at the top of it, there's an application layer that we don't touch in this course. Okay, so that's out of context for us. But why? So it is very true, right? It is the TCP, which is Transmission Control Protocol, right? Internet Protocol suite. Why is communication requiring this many number of layers? And what does each of these layers do? Right? The argument is this, right? Is that even if you just send a single text message, right, which you guys do, perhaps 1 million times a day, right? Because you've been influenced by marketing that you should send more text messages. If you look at that, right, there's a simple text message like, "Hi, how are you doing today?" Why do we need 5 layers of protocol to enable this text message to go from one user, right, networking device to the other user's networking device? And Jay Young, it is not about security. None of this layer actually touches on security at all. And we'll talk about security in its relation to the protocol. Layers of abstraction. Why do we need that? Why do we need? So have you guys taken like OOP, like object-oriented programming type of stuff, right? Like modules and abstractions. Why do we need that? So I believe Edward says uniformity in a word that is standardized. Yes, there's standardization, but why do we need to break up? And the question is, what are all these layers? What does the physical layer do? What does the data link layer do? What does network link layer do? And what does the transport layer do? Okay, I'll give you an example. Okay. The physical layout, and this will obviously get sort of addressed in more details as we proceed with the course, right? This week, okay. The physical layer deals with the signals that are being transmitted. At the very most part, this physical layer is not dealing about the medium. It's not about whether it's Wi-Fi or it's Ethernet, it's copper, it's over the air. This really says this, right? Remember the analog wave I've shown you, right? Can you guys hear me?
The sound is breaking, but now it's good.
Now it's good? Okay, yeah, okay. Okay, can you hear me now? Everybody? Yeah, please. Yeah, okay, good. Okay, so issues with it. Okay, so what I'm saying is this: is that the physical layer, right, actually deals with how ones and zeros are represented, either in digital form or in analog form. It's not about the cables. It's not about the coppers. It's not about fiber optics. It's not about the wireless. It's about how a single bit of information, either 1 or a 0, a logical 1 or a logical 0, right, is actually transmitted as a signal. Right. So that's what it is. The data link. So the thing is this, right? If there's a signal that's going through and forth, it needs to get addressed somehow, right, to a particular receiver. How does it know that if I transmit on Wi-Fi, that the data is actually meant for my network adapter? So as part of data link layer, there's something known as a MAC address or MAC ID. Has anybody heard of that term? MAC ID. Yes, okay. That's your hardware address, your unique hardware address. Is a 48-bit sequence, right, that allows you to say this, okay, we're sharing this channel, right? So think about it, right? You guys are probably mostly at home right now. Okay, and let's assume there are other household members, and more likely than not, you're not the only one using the network connectivity of your household. True. So there are other devices. Little brothers and sisters could be watching and gaming at this point in time while you're attending a class on Bongo. How does the data enter your household through obviously some kind of a modem that you have know from who the data or which device the data is intended for? Does everybody get that? Okay, so the issues that we have here, obviously, right, is to say this. Okay, well, we need to have some form of addressing, and MAC ID is part of the data link. And the data link layer does a lot of stuff, including error detection and control, including sort of the medium access control and so on. So we'll touch that. But let's assume now, right, that I've got this MAC ready, okay, but the MAC IDs only are visible within a local broadcast domain. Now let's assume that I'm trying to interact, right? Has anybody seen sort of a network topology diagram where it says, I'm at home and I want to access the network at BCIT? In your context, right, every device on your home network, you can actually see your network drives, your printers, your other devices, you can share files, right? And so on and so forth. The question is, if you're trying to access data on a server called learn.bcit.ca, I have a couple of questions for you. How is it that when you type in learn.bcit.ca in your web browser, it knows to find the server that's located in the basement of SE12? Have you ever thought about that? You're at your home network, right? And we know that there is more than one path to get to, right? If you look at the road system, right, to get from your home to BCIT. Likewise, there are many redundant paths on the network that allows you to go from your home, right, all the way to learn.bcit.ca. Anybody heard about something known as IP addresses? Right?
Yeah.
IP addresses are what we use, right, for purposes of what we call host-host communication, right, which means device to device, right? And we achieve that in a network, right, that is full of redundancy. And in fact, I would argue that the internet that we use is very ad hocly put together. Okay, so the idea is very simple, right? There is some form of routing that takes place, and that's why the term of a router, right? That gets us to say this, you know what, from my home network, I'm going to now get out of my home network into my service provider. From my service provider, they're going to go on to another service provider that the service provider has. And let's assume that I'm trying now not to just gain access to the data at BCIT in Burnaby, but I'm trying to gain access from the service at U of T, which means I have to go across Canada, likely through some fiber optic cable links, right, all the way through to Toronto, and then into sort of the networks of U of T, right? That whole process of getting your data through this network, right, and finding the path to the destination, right, happens all at the network layer, right? And the technique we're going to look at is something called forwarding and routing. So are we done? Right? At the physical layer, we have some ways of representing the data as a signal, so either analog or digital. At the data link layer, it allows us to communicate within a local area network, right? So I have the MAC IDs that are unique. But when I go across networks, right, so from my home network, say, to sort of my ISP network, right, to my data network, right, what we have then, obviously, right, is being able to get onto a network, right? We need to find a path there. But we're not done yet. So why? Why do we need a fourth layer called the transport layer? So we've gotten to the destination host. Why do we still need another layer on top of that? Let me ask a question. Maybe Lacey, okay? Lacey, how many applications do you have running on your laptops right now? Right. So Lacey is not responding, so I'm going to respond for her. Right. She has a Bongo session running. Right. If I look, sort of, and envision what she has on her screen, she also has a Netflix stream going on the top right corner. She has some messaging type service like a Discord or something, Facebook Messenger, that she's chatting with her friends, deciding what to eat for lunch. Right. She has a mail application in the background, and yada yada. Right. I'm making this up. But a normal day usage of a laptop, Lacey, right, would likely consist of more than a single application on your laptop. True? Chantel has 80, right? And so the question is this: even if I can get data, right? Even if I can get data, right, all the way through to the device, that's not sufficient because I actually need to get the data to the correct process. Does everybody see that? So what's intended for the web browser, right? The data for the web browser should go to the web browser. What's intended for my mail application should go to the mail application. What's intended for my Netflix streaming should go to the Netflix. Does everybody see what I'm trying to say? This is where the transport layer comes in because it allows for what's called process-to-process communications, right? And it's through the use of port numbers. I don't know if you guys have seen that. So there is something known as an IP port pair, right? This also equals to what we call a socket. Has anybody done socket programming before? right? Essentially, it's an IP port pair, right, that allows you to sort of do what is very simply networked applications. Okay, who took C from Albert? Anybody took C from Albert? I presume most of you did, right? Yeah. So Albert and I have been discussing, right? And I've always asked him, Albert, why don't you teach them socket programming in C? But anyways, the response came back in a very long discussion as to why that is not yet being done. But eventually, right? I like to see everybody. So if you ever go to the client-server option, you do a lot of socket programming. If you go to the datacom option, you do a lot of socket programming. If you go to the IS option, you might do some of socket programming, but mostly you're more on the higher level enterprise type of networks, right? And so on and so forth. But in any case, right, this IP port pair, right, is layer 3, layer 4. So layer 1, right, in terminology is the physical, right? Layer 2, right, is the data link, right? And then it keeps going, and then layer 4, right, is actually the transport, right? And then layer 4, right, equals to the transport, right? And then layer 5 is application, and we don't talk about that, and I'll tell you why in a few minutes. Okay, so all of these will be detailed to you, but I just want to give you a for you why I spent so much time in it, because this 5-layer approach is how we will approach this course. We'll go through layer 1 first, and we'll spend about 5 weeks on layer 1, and then we'll spend 2 weeks on each of layers 2, layers 3, and layer 4. Okay, so that's how the course is going to progress. We're going to spend a lot of time on the physical layer because it's the one time and only time that you'll spend on the physical layer. And then and then we'll touch 2 weeks on the data link, 2 weeks on the network, 2 weeks on the transport. Essentially, what that means is that everybody gets the same foundation, regardless of options that you go into. And if you go into sort of the datacom option, you do a little bit more on layer 1, as well as layer 3 and 4. If you go into the client server option, you do a lot of time on layers 3 and 4 only, right? If you go into the IS option, right, you do more on layers 3, 4, and 5. Does everybody get that? Okay, if you go into the DigiPro, if it was still offered, you'll spend most of your time actually in the physical layer, right? In fact, what they do in DigiPro is simply things like, how do you morph the picture of a cat, right, and morph it into a picture of a dog? Okay. So let's sort of continue on in the interest of time here, right? What else do we do? Along with sort of the 5-layer is of how we approach the course, right? We're going to spend some time on what we call the transmission medium. So these are like the coppers, the fiber optic cables, right? The coaxial cables. We'll look at sort of analog digital transmission techniques, right? We'll also look at things like multiplexing. How do you have multiple users use the network at the same time? Okay, a common thing that you might think of this is that all of you, right, have one access point at home. True? Right, you have a single access point at home. Okay, but at the same time, there are multiple devices actually using the same network. Even yourself, even as an individual, you likely have a tablet, a laptop, and a phone connected all at the same time. True? And in fact, because they're connected, you could have data to all of these 3 devices simultaneously at the same time. And I'm going to put simultaneously in quotes. Okay. So the question I have for you, right, is how do you think that happens? How do you think that simultaneous data transmission happens? In fact, I'll tell you one thing off the bat, it does not happen simultaneously. In fact, you're sharing. All the devices are not actually getting data at the same time, but you are getting it simultaneously in a perceptive way. Okay? And how I sort of expand to that, right, is simply this, right? Is that if I were to say this, right, there are 3 users in the room, okay, and I'm going to multiplex data to all 3 of them. I'm effectively saying this. I'm going to give time slot 1 to the first user, time slot 2 to the second user, and time slot 3 to the third user. And then it goes in a round robin fashion. So it goes 1, 2, 3, comma 1, 2, 3, comma 1, 2, 3. Okay. If I now say this, right, the time of transition for each user is not in seconds, but in milliseconds, or even shorter than in microseconds, or even shorter than in nanoseconds. Can you experience the fact that you're not getting data in real time?
No.
Exactly, because the time of reference. So humans, right, have sensitivity to time really down to the seconds, right? If I say this, right, Rana, right, how many seconds have gone by since you last spoke?
I would say maybe 10, 15 minutes. So
Sure.
by 60.
Yeah. Okay. But if I would say, how many microseconds have gone by?
Then
Do you
you
have a
will have to multiply it
Sure.
by. Yeah,
But
a
can
certain
you
fact.
feel microseconds going by though? Are you
No.
able to feel microseconds going by? No. Are
No.
you able to feel nanoseconds going by? I was like, I mean, just since the last time you winked, right? When you blinked your eyes, right? Multiple billions of nanoseconds have gone by. So if I say this, right, if I'm sharing time and if I make the time sharing imperceptible to the end user, right? In fact, you feel that you're the only person on the network, which is actually not true, right? So we'll look at techniques like multiplexing, right? And obviously, along with that, right, switching techniques that goes with it. Okay. And then we want to say and go in as part of data link layer, right? We're going to go through what we call error detection and correction. Okay. That means one very simple thing. Do you think all the data that's being transmitted over the air is without errors?
There has to be some margin of errors.
There must be errors. Okay. Imagine, right? If I just say this, right? And this is difficult to do on an online sort of a context, but in a real class context, right? There is always noise in the room. What I mean by noise is simply this, right? You're seated 50% to a class. The person beside you could be clicking away on the keyboard, on a mechanical keyboard, which is really noisy. That clicking of the keyboard is actually noise to you because you're trying to listen to me in a classroom setting, right? Or you could have somebody, eating a bag of chips, and those are the most serious offenders, right? The bag of chips, as they crunch the chips, as they sort of crush on the wrappers, right? That's all noise, and that actually impairs the signal that you receive, which is the lecture that I'm trying to do. Okay, so the assumption in data communications is that the physical layer is always impaired, right? And it's actually that's exactly right. It's noisy, and when the mechanical keyboard that you use and you're eating chips, right, it actually affects greatly, tremendously the person beside you, because everything that you do, right, in those contexts, right, is noise to the person. Okay, so we're going to look at that as well. And the question is, what when we look at this, how, number one, is do we detect that there were errors? And then if we can detect that there were errors, how do we correct it, right? It's quite amazing because at the end of the day, the end user assumes that there are no errors in the network because perceptively, that's what you do. But when we look into the details of the network, right, we'll see that, in fact, there is many sources of errors that can happen. Okay, and then we'll look at obviously the layer 2 protocols, how we do multiple access, have different users on the network, right? And then obviously control the flow of data, because we want to look at the issues of networking from a routing perspective, and obviously from a congestion control perspective, right? Networks can get congested. Who's attended a hockey game at the Rogers Arena? Anyone? Has anybody ever attended a hockey game at the Rogers Arena? No? Has anybody attended any sort of a sports event? Not hockey, like any sports event. Okay. What happens when a goal is being made in modern day?
Everyone cheers up. Or
everybody.
Yeah.
So that's what they used to do. What do they do now? Who has seen, every time that a hockey goal is being made, right? There are people recording video clips of the hockey. Well, not now. I know. I mean, I'm just saying the last time we were allowed to watch a sports game, right? And I'm just using hockey as an example, right? But every time a hockey goal is being scored, right, you can imagine people have their cell phones out and they're capturing a video clip of that. In fact, a video clip is captured from all angles of the goal that's being made, right? Being sort of from a social media perspective, because you have to show that you were there, right? If you're not there, if there's no video, you were not there. But can you imagine the burst of data that's required to send that out instantly? That's congestion. Okay, the networks get congested because everybody wants to send high amounts of data at the same moment in time. And the question is, how do we alleviate that? I'll share some insights to you of what we do. So if we have everybody user, right, trying to sort of transmit data simultaneously at the same time, right, the worst user experience is to kick off a user off the network, right? I mean, if you're an end user, right, and I say this, well, then everybody around you is trying to send data because you only pay $35 a month for your service. I'm going to drop you off the network and then provide the service to the person that pays $150 a month. Is that a good user experience for you, Chantel, if you're the one that's been kicked off the network? No, obviously. Okay, and service providers know that. In fact, they don't kick you off the network, but what they do very simply is this: they reduce your data rates. We'll halve the data rates, for example, right? And then we'll continue to keep halving everybody's data rate until such point we can clear off the sudden burst of data. Which means effectively, we rather give the end user the perception that they're actually connected to the network than they're being kicked off the network. Okay. So we'll study issues around routing, we'll study issues around congestion, right? And then obviously we'll look into sort of from a networking perspective, right? The local area networks, wide area networks, right? And then we'll do an analysis of what is called the TCP/IP protocol suite. And in this particular analysis, right, we'll use something called Wireshark. Has anybody heard of this term, Wireshark? It's a packet sniffing tool. Essentially, you can look at the data on the network and sniff the packets. Okay, and I'm going to say one thing. Okay, when you use a packet sniffing tool, right, you want to respect privacy. Okay, when we get to that part of the course, right, I'm going to get you to do a bit of packet sniffing around your networks, right? But if you're doing it at home, okay, if the data is unencrypted on your home network, okay, then I say this: do not sniff the packets of your little brothers or sisters. And you know it's from them because you're going to be able to see the packets and you're going to see the MAC IDs associated with all of these packets, right? Do not sniff that. Okay, and I say that because I think you should respect the privacy, right, of every individual that's on the network, right? But more so because sometimes it's better not to know than to know. True, Rana?
How so?
Well, do you really want to know what your little brother or sisters are actually doing on the network? What websites they're accessing, other family members?
Not the brother and the sister, but if I'm a parent, I would definitely want to keep tabs on what they're surfing, right?
Yes and no, right? So that goes into sort of parental measures and stuff like that, right? But in a general context, though, right, Rana, right? What I'm trying to sort of motivate is that we should respect privacy when we start using this type of packet sniffing tools, because we shouldn't pry into the privacy of other members in the household, right? And as we get to that, right, Jason, I don't know what you mean by facts, but we want to respect the privacy. We'll do a packet sniffing project, likely, right, in this course as well, to understand sort of the interactions of the different layers. But keep the analysis to your own data, is essentially what I'm trying to say. Okay. So that's really the course in terms of progression. Okay, I'm not going to go through these learning outcomes. These are in your course outline. They basically go into a lot more detail of what I just give you as a course description, right? I want to now just touch very quickly now on what the learning resources are, okay, and how the course will be evaluated, okay? There's a required textbook for this course. It's called Data Communications and Networking, okay? If you're ever interested in pursuing this field further, this is a nice book to have, even as a reference book. It's a rather thick book. I believe it's about 1,500 pages or so. Okay, I would say this: you don't have to buy. So it's not a cheap textbook. I think it's roughly $150 or so. I always feel that textbooks should be given away for free, or even at some nominal fair charge, right? But I will say this, okay, and I'll leave it as that. You should get a copy of the book, right? But you don't necessarily, right, have to buy it from the BCIT bookstore directly. Okay, there are many ways of renting the book. There are many ways of acquiring the book in a legal way that is cheaper than, I believe, what is being posted on the BCIT bookstore. Has anybody looked at what it costs now? Is it $150, $200 roughly?
Yes, Something close to that. There is international copies where it can be ordered from lots of sites for way cheaper. So
Yeah. So what I'm saying is that you should get a legal copy of the book, I think, right? Because I think that a fair price for any textbook is roughly around $50, $60. We've talked to the publishers, see if they can actually drop the academic pricing on the books, right? But they have not yet been able to do so. But I'll say this: it's not, you are required to have this book. In particular, if you intend to pursue this further, this is a very good reference book from a comprehensiveness point of view. Okay. The second thing you need is a calculator. Okay, and I say a basic scientific calculator, I mean just the ability to do, if you haven't remembered, things like sine, cosine, tangent, right? But really we'll just do sine, and it's minimal, right? We'll talk about that as we get there. The other function that you need from your basic calculator is a log function. In an in-class setting, right, I'll tell you that you cannot use your phones as your calculator, but I guess I have no way of administering that now because it's in sort of a remote. But you know, get the calculator, learn how to use a calculator. That's important. Okay. There are two other books that I'll also list here. One's called Computer Networks, and one is called Data and Computer Communications. The book is by Tenenbaum, and one is by Stallings. These are two also textbooks that are very widely used at all the institutions around the world that covers this topic, right? So the Computer Network book is more of a computer science focused book. The Data and Computer Communications by Stallings is more of an engineering-based book. So you can take your pick, okay? The book by Forenza is a very detailed book, actually. And it's in fact used by both undergraduate and graduate programs. Okay, so but feel free to reach out. The more widely you read, the better it is for you. Okay. So how do we approach the course? Right, it's a long session. It's a 4-hour session, but it's also one where it is more traditional in terms of its approach than some of your other courses that you might take at BCIT. What do I mean, right? Every week, I want you to pre-read the material, and I'm going to go through detail with you shortly to show you how you actually do that. Your goal is to read at least one chapter from the textbook, and I'll post that, and I'll show you how you actually get that information. Okay. You will attempt, obviously, the lecture and lab combination, which is the 4 hours, right, where the system automatically takes attendance. Okay, and then you'll write a lab and quiz, right, covering the material every week, right, for the material that has been covered, not just in the previous week, but in the previous weeks. So what I'm trying to emphasize here is that the course is sort of cumulative and comprehensive as it progresses. Okay, so maybe this is a good time to sort of show you the course website. Okay, so let me pull this up. And then let me pause the screen share and share a different thing here. Can everybody see the course webpage on your screen share?
yes.
Okay, good. Okay, so you'll see here, right, that this is the course webpage. I use this mainly for two things, right? The most important tabs are the content tab and the activities tab. Okay, so if we go to the contents, right, let's get it out of this responsive mode. Let me just drag it a little bit. Okay, does everybody see the content here? Okay, where you are to do your course readings, right, you'll find them always in the reading material tab. So every week, right, say your class is on a Saturday, I'll post them usually by Monday or Tuesday. Okay, so if you click on sort of the reading material, right, it will tell you, okay, for this week, right, week 1, I want you to read, you know, chapter 1.1 and 1.2, and then, you know, in the network models, 2.1, 2.2, 2.3. Okay, so this is where you obtain your reading material, right? And I update this on a weekly basis, depending on the progress that we make on the previous weeks. Okay, and then if you go back to the table of contents, right, you'll see one other thing, right, is the actual lecture material that we'll use. Okay, so in this case, right, if you load up on module 1, right, you'll see, okay, this is what we do for this week, right, in addition to module 1, right, and we'll get to that after the breaks today. Okay, so that's sort of the lecture material that we have, module 0, module 1, and I'll post that up along with the reading list. Okay, occasionally I also post what's called study material, right, and this is where you'll see, okay, for this week, right, it's really a math refresher, numeral systems, if you've already forgotten it from your Comp 1113. right? Some notations that we'll use called metric prefix, right? Very large numbers, very small numbers, and then a quick refresh on logs, okay? This is not a logs course, it's not a math course, but essentially we'll use logs in a couple of situations when we calculate something known as power ratios and dB, and also Shannon's capacity theorem, right? But I just want you to get some review of logs in case you haven't done so. Logs are actually quite important. You'll get also a review on it when you take the algorithms course, right? So just spend some time, and I'll go through those with you later. New to this offering, because it's online, you'll see that there's a lab material tab in here. And in this case, right, I posted quiz 1, just page 1, right? So as I said, you don't have a quiz today, but I also want you to do a lab exercise associated with it. Okay, and I'll talk about some of the rules. Essentially, I don't know if this model is the best to run it, but we'll try it for a few weeks and see how it goes. Okay, the reason I cannot only just administer this lab on D2L is because there's sort of math involved with it. So my goal usually in class is that all this happens on a piece of paper. Okay. My hope is this, and we'll try this today, and not for marks anything, but really your answers need to be sort of handwritten. Okay, so that's sort of important, and obviously handwritten in a way that's legible, so I can actually grade it. And I want you to solve, when you solve problems, right? I want you to obviously show all your steps, because it allows you to get partial marks. Okay, and obviously you want it to be clear. Okay, and this is just a policy that, you know, no cheating, no da. So my plan to run the quizzes on a weekly basis or exercise is that there'll be some allocation of time, right? In this case, it will be 30 minutes, but because it's a non-graded assignment, I'm not going to take that into consideration. But you will do the quiz in real time as I post the questions, okay? And then when you're all done through with the quiz, right, you will either take a picture of it, scan it, right, whatever you can do, and then upload your quiz, your completed quiz, in a PDF format. So if you take pictures of it, you can quickly assemble that, even Microsoft Word, to output a PDF. And then you will submit it into the folder called Lab Exercise. So if you go back to Activities and you go to Assignments, yes, you can do handwriting on tablet. That's fine too. So I don't know. So that's preferred, but I actually don't know if everybody has a tablet that you can write on, but that would be preferred. But you don't have to. You can just simply write it and then take a picture of it and then export it as a PDF, right? And then submit it to sort of Lab 1. Okay, and then all of it happens within obviously the single time frame. So that's the thought I've had. This is not the only way that we can run this. I'm still trying to decide what's the best way of administering a quiz remotely, but in this case, it will be a quiz that's actually time boxed. Okay, and I'll go through that with you guys. But essentially, that's what it is. I will display the questions to you in real time. You'll work on it, and then at the end of the lab, right, you need to submit it right away. Okay, 2 restrictions. You're only allowed 1 submission, meaning you cannot do multiple submissions, and it must be in PDF format, because I'm going to grade it on D2L. Right, I'm going to annotate on it, and then you get your marks based on that. Okay, so 1 submission, and then 1 file for the submission. So not 10 JPEGs, but 1 single file assembled into a PDF. And we'll trial that, right? If that doesn't work for everybody, we'll find a better way that works for everybody. But that's sort of the approach. Okay, so let's get back to the class first. Okay, so this is how the labs will be done. I think this answers the question from a while back that Jae Hyung was asking, right? Jae Hyung. Did that answer your question on quizzes and lab exercises? I'm trying to go back and load up the question. There was a very question early in.
I think he was asking about the deadline of the labs.
Oh, yeah, okay. So the deadline of the labs, right? I couldn't find it, but in any case, the deadlines, right, is on every quiz, right, I will tell you. So in particular, if you look at this quiz here, right, I'll tell you that it's actually due within 30 minutes, right? If it's a lab exercise, then obviously the duration is much longer. Okay, so on every quiz you'll see and you'll be told ahead of time, right, what the deadline is. The quiz, obviously, it has to be handed in on the day off, right? In fact, it will be time boxed to the 25 minutes, 20 minutes, 30 minutes, depending on the number of questions I have for you on that quiz.
So it's either or, but not both?
Yeah, either or. Exactly. Okay. Any other questions on that? So again, this is a non-proven concept. There is one tool, yes, previous weeks. So not just the previous week, but the previous weeks. So everything we've covered to date. Okay. And then at times, right, I'm also going to post things like study material. I might post some supplemental material, right? So they're empty for now. And then, of course, your assignment will be posted in the assignment tab. Okay, so this is how you use it. So what do? Every week, right, your goal is to go to the reading material, figure out what you have to read for the week, okay? And then at the same time when I post it, right, I will also post sort of the lecture material. As I said, some of these lecture materials may be posted as an MPEG file, which is a video, right, playback, which means I'm doing some lectures and I pre-record the lecture. You can actually listen to it asynchronously. Okay, so that will be one form that we can actually do. And then obviously the lab exercises and quizzes will be posted here, right? And then obviously in real time, I'm going to do that on Bongo as well, right? If it's a quiz, right? And then the other tabs that you'll use really is the assignment tab, right? Because this is where you submit your assignments. This is where you submit your quizzes and so on and so forth, right? And then obviously the other thing that do is the virtual classroom, right? Which is what you guys are on right now. Okay. Any questions on that? So if I cancel this, go back to the slides, share that. Okay, so I'm going to try to wrap this up very quickly now. I have a few slides to go, and then we'll take a break. Okay. Okay. So let's get back to sort of the slides. So this is what I mean by doing all of these previous quizzes and so on and so forth. Okay, how will you be assessed, right? This is what I think most of you are very much sort of concerned about. Okay, number one. Okay, there will be assignments, right? They will count for 30%, and there will be 4 of those throughout the term. So roughly every 3 weeks there will be an assignment. Okay, there will be either a lab exercise or a quiz weekly. Okay, that will count for 30% of your mark. Okay, and then of course, right, if we can go back in person in July, there will be a final exam to be held in person on July the 18th. Right. So to address your question, Chantel, is that I know that students have been able to get PDF copies of the book relatively easily. Okay, I'm not a big fan of PDFs because I like to read a book when it's tangible to me. But I think that if you're able to sort of get at least a soft copy of the book for now, it should suffice for you as you sort of go through the material. Okay, until such time, if you prefer a hard copy of the book, which is what I usually prefer, you could do that as well. Okay, so let me get back to this, right? So the assignments are worth 30%. Okay, 4 of those, roughly every 3 weeks you get an assignment, right? It's individual sort of work that you have to do on that, right? Are we allowed 1 submission? Yes. For assignments, also 1 submission. You should not have to do multiple submissions along the way, because essentially when you're done with it, right, you upload a PDF copy, right, and then that gets forwarded to the marker. Okay. So I grade everything in this course with the exception of the assignments. So I have a marker that helps grade the assignments, and the marker would prefer. In class, it's actually a handwritten copy, right, or a printed digital handwritten copy. But essentially, right, the assignments do not allow you to do multiple submissions. You simply do 1 PDF at the end when you're done, and then submit it before the deadline. Okay, Rana?
Okay, thank you.
Yeah. And then if there's a final exam, it will be held on July 18th. Now, I should know by week 6 of this course. So in 6 weeks or 7 weeks, right? I think as we enter May, we'll get visibility as to when, if possible, or if we're even allowed to go back in person. In the event that we cannot do that, right, then what will happen is that you will have a final project in lieu to sort of take over as your final exam. So what I mean is that there will be a replacement of the final project with a individual project, right? In the event that we cannot have a in-person final exam. Okay, and more details of that will come up maybe by week 7 or no later than week 8, because we need to get the project going and so on and so forth. Okay. The second thing is this, right? Your assumption is that every week, the lab exercise that you will do is a quiz, right? So why do I do this? Because I want you to keep pace with the material as we progress through the material. I don't want you to sort of get too far behind. Okay, the weekly quizzes, the weekly lab exercises, right? Your assumption is that it's actually going to be a quiz every week. Okay, it's just that at times, right, where I feel that the concepts are a little more difficult, I might just let you do an exercise. And the difference is very simple. A lab exercise is open book, a quiz is closed book. Okay, it's essentially the same type of questions, right? But quizzes are closed book, and the lab exercises are open book, which means you can reference your material. But your goal is to come to class every week, right? Prepared to write a quiz based on the material from the previous weeks, so that you're learning along the way, and you're not only trying to cram the material right before for an exam or some deliverables that are actually due. Okay. Any questions on the evaluation criterias? As I said, I will grade everything in this class. Right. So as I said, whether or not it will be in person, I will say this, right? It will be at the directive of public health, and I'll make a formal announcement once I receive some clear directives as to how this term will progress. In fact, there is talks even now that the fall semester could also be entirely held online. Okay, just so that you guys are aware. So if you're wondering whether or not we'll finish the term online or in person, it will be very much at the directive. So I'm not going to make the decision. It will be the decision made in conjunction with the institute, BCIT as an institute, and public health directives. Okay? Is that clear? So I'm just responding to some private messages that I've been getting on sort of the on the chat system. Okay, so I grade everything in this course with the exception of the assignments. I have a marker that helps with that because it's multiple repetitive copies of that. Okay, so usually they're very rare there are issues with the grading, but if there are any, right, just tell me that you want your marks reviewed, and I'll forward you what's called a regrade request form. So it's just simply a form that you fill out and tell me what you think are the issues, why, and so on, so I can take that offline and then review that. Okay. Okay, so very much to wrap up sort of the this deck of slides, right? The entire course wrapped up, sorry, not wrapped up, but administered on D2L, right, which is the Learning Hub. Okay, there's a certain level of expectation that you can actually solve algebraic equations, right? Do some log problems, and we'll review all of that. So I don't want you to worry, and a bit of basic trigonometry because we deal with sine waves. Okay, so if it's grade 10, if it's grade 9, if it's grade 11 that you have to sort of refresh, we'll do a bit of a refresh as we get there. Okay, you are required to read the books, okay, the textbook as per the prescribed chapters. It helps you tremendously. Okay, so rather than come into class and just let me go through a deck of slides, I think that if you do some pre-reading, the minimum of what you should do is that even if you don't have time to read the book, is at least to browse through the material. Okay, so you're not coming in just to gather what I'm teaching you, but you're coming into class to be interactive, and you're coming to class to learn. Okay, late assignments will not be accepted. No makeup quizzes, exams of any sort, right? Obviously, the exception is if you have a documented case of medical or other reasons that you need to do that. But in general, right, nothing late will be accepted, no makeups, and so on and so forth. Okay, the stuff in blue is more department-wide. No recording of the classes is permitted unless you have prior permission. So my understanding is that you have to go to the program head and request to record, but you have to sign a consent form of some sort. Okay, the attendance is mandatory. Right, PTS has a 20% requirement of maximum misses. So with 12 weeks, you can at most miss up to 2.4 classes. Right, but you're encouraged actually not to miss anything because then you fall back quite a lot each time you miss a class. Okay. In the day sort of in-person classes, right? I say this, but I think it applies also for online, is that when you're attending class, you should not be chatting, gaming, or social media. Right? I mean, this is basic respect for you, right? While I don't see your face when you sort of game and chat online, but I think it's to the best of your advantage to pay attention in classes. Okay. Last but not least, right, I've been asked to sort of share this with you, right, is that plagiarism is a very serious violation in academia. Okay, so it's not about you cheating, it's not about you plagiarizing, and impacts only the students that does that. The students that share that information is also right guilty of cheating or plagiarism. So please, if you're here to learn the material and not try to cheat your way through. Okay, PTS and day school, this is taken very, very seriously, right? So this is really just a warning. This is really just an encouragement, right? You want to follow the highest level of ethics, okay? Which means that you really want to do the work yourself. It's better to make a few mistakes, learn from the mistakes, right? Then try to sort of use other people's work, right, as yours and not learn anything, right? You're a student and your responsibility is to learn the material. And that's the encouragement that I have for you. Okay? Any questions so far? This is really the course schedule. This is available to you on the course description, course outline, right? But essentially you'll see this, right, is that we'll go through roughly a chapter and sometimes more on per reading, but the reading are not the entire chapters, right? Exactly, right? So that's a really good statement with what Chantel just made, right? Ultimately, right, I always tell the student this, right? In any course that you take, right, the knowledge that you acquire, right, is yours to keep for life. It's yours. You are the person individually that knows how much you have attained, and eventually, right, not knowing the material, if you pursue in a particular field, will only catch up to you in life later. Okay, so that's a really good advice from Chantal. I could have said it any better. Okay, but I want to go back to this course schedule, right? Essentially, we'll cover about the first 5 weeks that you see, weeks 1 to 5, right, up to chapter 5. This is the physical layer. And then we'll go roughly a week and a half to 2 weeks, right, on each of the other layers that I showed out. There's roughly an assignment due every sort of 3 weeks, right? And you will at least get 2 weeks, so 10 days roughly to work on the assignment. Okay, what's tentative right now is whether or not there will be an in-person final exam. Okay, but minimally, right, if we don't have the in-person final exam, then what we'll do is we'll have a project that I will release to you by week 7 or 8, right, for you to work on. Okay, any questions? Anyone?
Yes, when we get the assignment, are we able to finish the assignment, or do we need the material that is provided during those sessions that follows the assignment to complete it?
Both. So when I release assignment, I think that usually I release it when I've covered about 75% of the material. You do at times also require an additional half of a session to make up for that, right? But in any case, the material, when you get the assignment, you will not be due until you have been fully taught the material. Which means that, let's assume that I finish the teaching of the material in week 3, then the assignment will be due in week 4. Okay. But I might release it in week 2. Do you see what I'm saying?
Yes.
I might release it in week 2, complete the material by week 3, and then it's not due until week 4. So
we still have technically 5 days to complete the assignments for those who decide to have a late start on it.
Minimum of that.
Yeah.
My goal is that I'm releasing the assignment when I've covered at least 60 to 70% of the material. So that will be, say, I covered all of that by week 2. Week 3, I'll finish the remaining 25% and then get going on with more material. But the assignment will not be due until the week after. It's not right to get you to submit it right on the day that I teach the material.
So we can have an early start on it, is what I'm really asking.
Yes, exactly.
Start right away. Okay.
Exactly. My goal is to give it to you at least 2 weeks in advance, but you may not have learned everything, but you will definitely learn it 1 week ahead of its being due.
Thank you.
Okay, and then usually in PTS, what I do is that at the beginning of class, when the assignment is due that day, I take questions. So the assignment won't be due not at the beginning of class, but will be due at the end of class. So you get another opportunity to ask questions.
Perfect. Thank you.
Okay. Any questions on the layout of the course? Okay, so if not, then what we'll do is we'll take another break, right? For now, let me see, it's 11:45 now. Let's take also an 11-minute break. So we'll resume at 11:55. Is that okay?
Sounds good.
Yeah, so we'll take a break, and then once you come back, right, we'll go through the course and see how far we can get today. Okay, I'm not as concerned about being behind on the first course because it always happens, but I wanted really to lay out the entire course for all of you. And then next week, let me just type this break, right? And then resume 11:55. Okay, so next week, then what the course takes on a different sort of approach, right? Usually the first part of the course is the review and some quiz, followed by new material, and then followed by the new lab. Okay. So let's go take a break, and then we'll resume at 11:55. Chantel, are you there? Yeah, did you get my response on your private message? Oh, no. Oh, I said no. I saw it. Okay, so let me just type it to you. Is that clear, Chantal? Yeah. Okay. So don't worry about it, right? As at the moment I know, I'll share with the whole class. Okay, it's everybody sort of back here now. So how's the material so far? Is the pace okay? Yeah. Does everybody find the 4 hours to be long? I mean, essentially we've already gone through. We've already gone through 3 hours. It's not so bad, right? I think that if we take the appropriate number of breaks, the 4 hours is quite manageable, right? So I've always asked the students, right? Do you prefer a 4 hour straight class, or do you want to come in twice a week, right? I've been told that actually they prefer, for many different reasons. Some of them actually even feels that, you know what, having a 4 hour class when in person, it was much more efficient that way, so they don't have to commute that many times to BCIT in a week. Some of them like it because they only have to pay for one parking essentially once per week rather than twice per week. But again, you know what? I think that if we sort of pace ourselves correctly within the 4 hour course, a class, right, it's certainly quite manageable. Okay, and if there is an additional need for a longer break, please feel free to voice that. Okay. Okay, so let's get going. Yes, the reading, if you guys can keep it up, it will be awesome. Again, right, I will say this again, and I said this because I really want to drill into you, right, is that the material that you learn from every course is yours to keep forever, right? There is very sort of the relationships and correlations in terms of how much you read in terms of breadth-wise, right? I'm only one source of information. Reading the book gives you a second different vantage point describing the same type of information. Right, reading a second book gives you another vantage point. So the more widely you read, the more complete the picture and visual you have of the information that's being sort of communicated to you. Okay, so please, yes, do read the book, right, as much as you can. Okay. Does anybody have any questions with the logistics of the question? Of the course, sorry, not the question. Okay, so let's use the remaining hour today, right, and just get through as much as we can in terms of the lecture material. I will go for about 45 minutes on the lecture material, and then I want to spend the last 15 minutes or so to sort of let you guys take a look at the quiz or the lab exercise for today, right? So just to give you an understanding of how that will be conducted, okay? So really what I really wanted to accomplish today in the first lecture was to do two things, right? Give you a roadmap, right, of what the course is, right, from the week 1 to week 4, list out all the expectations, and so that you're aware of what your responsibilities are in this course as a student. Number 2, I really wanted to motivate you, right, before we actually get into the details of what we study, why we're even doing this course. Okay, so this is the likes of why we will have in terms of everything being in a networked context, right? So your cloud services, your data in remote locations, but more so into the future where we have 5G networks on the rise, with IoT on the rise, right? And how communications, right, has an impact on your life personally as an individual. Okay, it's very important to keep that in context, because otherwise, the technical stuff that you sort of go through, right, becomes quite questionable as to why you're studying that, right? And I always want you to relate back to the context, right, in real life. Well, we need to do this because we want, very high throughput. The question then is not just because we want to have very high, how can we increase throughput even further? Right? And then how can we reduce latency even further? So we'll do a lot of timing analysis, we'll do a lot of throughput computations, right? And so forth throughout the course, okay? So those are the two sort of things. And as a key takeaway, right? Very simply, right? If you cannot live without a day in a networked world, right? And I'm talking about data networking, not social networking. Then it is important in your field that you have a general, deep, good understanding of this material. Right? Because everything that you do, regardless of the field that you go into, in most cases, most of the applications that you develop, right, will be some form of a networked application. Okay, so let's get started. So this is a very small deck of slides because I want to facilitate some discussions here. Okay, I really like my lectures to be interactive, and I'm trying to make the best use of this online e-learning mode and still remain interactive. You can unmute yourself or you can type into the public chat, right? So what I've shown you here is a very archaic picture, on purpose actually, of some kind of a desktop machine trying to interface with some kind of a mainframe. But obviously, right, the days that you interact with these days today could be anything. Could be a tablet, could be a phone, could be a laptop, but it doesn't really matter. Okay, and you're trying to interface with some kind of a remote server or storage, right, or content server, right? It doesn't matter whether it's in a network facility like SC12 at BCIT. It doesn't matter whether it's AWS as a cloud service. It doesn't matter whether it's a service, right? Whether it's an infrastructure. It doesn't really matter. What we care about, right, is the stuff in between, which I've annotated, right, with 3 question marks. So if I were to make this a little bit more concrete in this question, right, is what I'm trying to ask everyone is, what do you think happens in between, right? And if the example is that you're trying to access module0.pdf from the Learning Hub for this deck of slides, what do you think happens? And I want to just get an understanding of what you guys think happens. So right from the browser where you type in learn.bcit.ca, right? Clicking through, getting the files, right? Think about the network, the path that it takes. Think about, maybe you might have heard of things like IP addresses, MAC IDs. Think of the messages that are exchanged. Think of the physical layer. Does it only go through one type of network? Is it just Wi-Fi? Is it Ethernet? Is it fiber? What happens? Essentially, right, you want to put yourself in the shoes of a single bit that makes up, if this file was 300 kilobytes, right, so there'll be 300 kilobytes times 8 number of bits. Let's get started. What do you think happens? We can. Everybody should chime in with something, hopefully, right? What do you think happens?
Well, first of all, I think it's going to be different types of networks, not only one type.
And you're very right? Because the moment you go on a wired network at your last mile interface, which means you and the access point at home, it likely goes on a wired network, either fiber, either coaxial, depending on the service that you have. Okay. And then it goes further from that. You might even go through some fiber optic network, right? And then eventually get into the data center at BCIT. You're absolutely right. What else? Chantel said request. You guys have done web programming, haven't you? Right? You guys have probably done sort of get messages, put messages, right, in HTTP, right? What's HTTP? Anyone? So usually, right, in networked applications, right, there's usually a request response pair, right? So your get and put messages. Yeah. HTTP is really a protocol only, right? But why do we have different protocols like HTTP for web transfer, FTP for file transfer, SMTP for mail transfer? Why? Why different protocols?
I think data is packaged differently depending on the type of the data. For example, if you need to access a website versus if you need to download a file.
Yes, but why? Why is it packaged differently? You're absolutely right, but the question is why? Anyone? Readies the computer, how to go? Yeah, so all of that are correct, right? So this is what we call protocols, okay? But essentially, they're different protocols because of different data usage models. Let me explain to you one thing, okay? Think of you guys have probably done FTP and HTTP, right? Okay. Think of the data transfer, the interactiveness of the data transfer in an HTTP protocol, okay, for a minute, right? How do you gain access to the data? Then think about how you do data transfer in FTP. Are they different or are they the same? Is the level of interactiveness in an HTTP session different from an FTP session? Hello, can anybody hear me?
I'm guessing yes.
Yeah. Are they the same or are they different?
The level of interactiveness is different.
Exactly. And the reasons why we have different protocols is because if you start to think about it, right, when you access sort of data using HTTP, it is almost a very highly interactive session because you're clicking and you're reading, you're clicking and reading, you're clicking and you're reading. The protocol obviously is very, and in most cases, right, it's very short packets going back and forth, right? Think about mail, right? Comparatively, if you do FTP, the interaction is very different. You basically sit there and say, I want this file from this server. That's it. And then in sort of Shenkai's example, right? I don't know if you guys know, but Shenkai loves to watch a movie called La La Land, right? Because apparently it won the Academy Awards Best Picture a few years ago, right? Shenkai? Okay. And he would insist, obviously, that he only watches it, right, in full 4K resolution, which means he's downloading a file that's probably 2 terabytes in length. Right? So think about that, right? So in an FTP session, right, really then it's a request only, okay? And then followed by data coming from the server continuously for the next hour or two, right? That obviously is a very different usage model as opposed to HTTP, and therefore the protocols are different, okay? So there's this request response message that is common to both, but the interactiveness is different. The number of error conditions are different. The number of fanouts are different, and therefore, obviously, right, a different protocol. Okay, what else? So Shenkai also mentioned something like DNS. What is a DNS? Why do we need DNSs? Anyone? Have you guys heard of the term DNS? Yeah. So what does it do? Right. And why do we need that?
we need them to translate the URL to a specific IP address so it will get to the correct destination.
You are now muted.
Sorry, Rana, can you say that again? I muted everybody.
I understand. Yeah, noise was actually, yeah.
Yeah, can you say that again? I muted everybody again. Sorry about that. Yeah.
To transfer the URL to an IP address so that the message or the packet gets to the correct destination or correct address.
Right. So why don't we just use the IP addresses all the time? Why do we need to translate? So for example, right, if I tell you that the web server for the D2L system is 142.242.10.6, if I tell you that, why don't I just say this? Why don't you just go HTTP and then 142.242.10.6? Why do we want exactly? Because humans are terrible at numbers. Right, just like what Yongjun is saying, right? Humans, in fact, in the early days, we used to be very good with 10-digit numbers because we will pick up the phones and then we will call someone, right, on their 10-digit numbers based on memory. But these days, we're even losing that minimum ability to do so because we actually call everybody either through the use of a digital assistant like Siri or Cortana, right? Or we just go through a phone book, an address book, right, that is pre-populated, right, with the contact numbers of individuals that we want to call. Okay, so DNS is based on a domain name server. It translates, obviously, right, a domain name to an IP because remember, right, in layer 3, right, IP is where we get the data. Okay, what else happens, do you think? So we talk about the protocols, right? The protocols are actually the application layer. That's layer 5, right? We talked about sort of the need to translate the domain names to IPs. That's a layer 3 thing, right? In the IP addresses, right? What else? We talked about the
translate the bits to signals and then back from signals to bits again on the destination side.
And that's the physical layer. Right? And then in between all those, right, with the IP, we can do routing because we need to find the path. Remember, right, as I said, if you think of the network as a road system, there are multiple potential paths to go from source to destination, which means from your home computer to BCIT's network. Right? And then obviously, once you get to your local area networks, right, you need the MAC IDs because you need to get, obviously, right, the data to the right network adapter. And I'll say this, if you look into a modern day device, how many MAC IDs do you think you have? Just like your cell phones. How many MAC IDs do you think each of your modern day laptops or cell phones will have? Is it just one? If you just take your modern day cell phones, go to the About page, right?
Doesn't each device has its own MAC?
Not each device, but each network adapter. So in fact, most of your modern day cell phones or laptops may have 2 or 3 MAC IDs, right? So one MAC ID for your Ethernet, one MAC ID for your Wi-Fi, one MAC ID for your Bluetooth, and then maybe even one MAC ID for your NFCs, right? So MAC IDs are assigned uniquely to each network adapter. So that's a layer 2 thing. Okay, so the reason why I motivate all of this is because I want to give you, right, now a deeper understanding, right, of the key takeaway of this course, which is the TCP/IP protocol suite. It's essentially, as I said, based on the course online, we'll spend about 5 weeks on the physical layer, and then go on to the data link layer in 2 weeks, network layer 2 weeks, then transfer, and we won't do the applications. Okay. Does anybody remember, right? So this is the key takeaway. If anything, this is your most commonly asked interview questions. Can you tell me what's the function of the transport layer? Can you tell me, right, if I want reliability in my communication, which layer is responsible for that? All right. Can you tell me how routing works in layer 3 or the network layer? So just again in terminology, physical is layer 1, data links layer 2, networks layer 3, transports layer 4, applications layer 5. Okay, 2 things I want to highlight right on the first day is this. The physical layer does not actually define the physical mediums. What I mean by that are the copper twisted pairs, coaxial cables, fiber optic cable, wireless channels. No, it does not. It represents a layer that helps us represent the information into signals. And we'll talk about why we need to do that. So that's a physical layer. Okay, the data link layer, if you recall, right, layer 2, right, allows us to add unique addresses to it. Because even if you have a signal, let's assume that I've created, a sine wave for transmission over wireless. Well, how does the signal know who the data contained within that signal is intended for? Right? It's really up to the data link layer to do that, because what you have is now in your header of the data link layer, you're going to add in some MAC IDs. And that's your network adapter. As I said, in a modern day phone, you might have sort of a adapter with a MAC ID for your Bluetooth, one for your Wi-Fi, one for Ethernet, one for NFC. The data going through all of these networks, right, adapters are different. And therefore, they need to go to the appropriate network adapter. That's your data link. But because we know that the physical layer is always assumed impaired, which means, right, the physical layer itself, right, doesn't have much of a guarantee that there are no errors. I mean, I'll give you an example, right? Let's assume I'm giving a lecture here, okay? And then I'll do one experiment for you guys. I think I can do this. I'm going to unmute all. Is the channel now very noisy? So if I were to run a lecture, in this, would you argue that the information that you get is much lower than if I were to run a lecture in this mode? Does everybody see the difference? Right? And does everybody see the difference in the experiment that we just did? If I mute everybody, which means effectively I'm suppressing all the potential noise in the channel, right? The channel between you and me is now obviously what you hear on your headphones. The clean channel, which is the non-noisy channel, right, has much lower errors potentially as compared to a channel that's actually very noisy. And the fact is that when you transmit data across the channel, there are no guarantees that the channel will be clean. Does everybody see that?
Is that because when you muted everyone, the data basically had to went from to one direction, so from one point to the other?
No,
versus the other way?
No, what I mean is that everybody else chattered in the background when I unmuted everybody, contributes a signal to your ears, and it is not the signal that you're looking for. That's the noise. Okay, we'll very soon, right, go into as I can show you this, right, is that when we proceed further in the course, right, we will look at something very simple as what was called the signal to noise ratio, right? And this, right, is defined as, right, the signal power over the noise power. And you want this quantity to be as high as possible, because you want, in the presence of noise, as we transmit any data, right, we want the signal power to be much, much higher than the noise, as in this case. So if I unmute everybody again, right?
You are now unmuted.
Listen to all the background noise. Well, in this case, there's a bit of feedback. But if I can have maybe someone a little bit, right, and just create some noise and type on the keyboard, right? The noise level goes up. Right, I hear some cups in the background, some kids talking, and so on and so forth, right? And that obviously interferes, right, with the message that I'm actually trying to get at. Okay. So the data link layer, in addition to giving you the data, right, also allows you, right, to do what we call error detection and correction techniques. So we'll spend about a week on it. It's actually very interesting of what we actually have to do. Okay, so if you're only trying to sort of communicate within a local area network, like within your home networks, right, all you need to do is, well, have the MAC address, and then I'm going to send some data across. But if you want to go across networks, this is where the network layer comes in. Then this is where layer 3 is, because you now need IP addresses. Right? And the idea that we need IP addresses is very simple, because we need to find a path through the process of routing, which is done in network layer, right, to get to the destination. And the path is not just simply, well, find me a path. You're always trying to find the best path. So if I put the analogy back to the road system, right, when you drive or take sort of some kind of a ride-sharing sort of ride-sharing, how do you decide which roads or which roads to take to go from your source to destination? Is it always the same, or can it change depending on the traffic congestion of the moment?
It can change depending on the traffic. Well, that's one aspect. Sometimes you don't mind having to spend more time versus maybe getting away from the highways, for example.
Right. Exactly, right? And if you start to think about the data that goes between in all of these networks, they're exactly doing the same thing. But there are many other factors that considers. Number one, my goal is this: if I have, right, in your case, right, you would trade off time, right, than to get on the highway. In data networks cases, they want to get there meeting a certain latency requirement, right? If the delay is too large in a real-time speech, then what you hear is very, very choppy audio. Okay, so that's what we'll take a look at routing, and it's simply not just highest throughput, lowest latency. There's a cost associated with that as well, because no one service provider owns the entire network across the entire globe, right? So service providers, in fact, have service providers, and they have to pay, right, or cross-license, right, so that they can use somebody else's network to transmit their data. Okay, so the network layer gets us what we call a process-to-process communication, right, which means host to host. But we're not done yet. Remember, right? Yes, I have the ability to transmit a signal. I've been able to get within the local area network through MAC IDs and layer 2. And then when I get to the network, I can go across different networks, right? But once I get host to host, I still need to get to the application. And this is where the transport layer comes into play, right? Is that I need to get the port numbers, right? Remember the IP port numbers that I talked about, the socket programming? Because I really want to get now the data, not just to the hardware, but I want it to get to the correct process or application that needs the data. So this is the path of the TCP/IP protocol suite that we'll cover, and this is detailed for you in the next stack of slides. But this is the key takeaway. This is, if anything that you get out of this, right? As I said, you must have a good understanding of this TCP/IP protocol, because this is where the interview questions will come from. Okay. What we don't touch on in this course is the application. But the application, as I will say now, is not your Internet Explorer, is not your Chrome, it's not your Safari, it's not your Outlook. The application from a data communications perspective, right, is the actual protocols, because we care about the protocols. The applications, as I just named, like the Safaris, the Chromes, they're just nothing but GUIs. But what really gets sent underlying that, right, whether it's to Safari or to Chrome, right, is really HTTP request and response pairs, gets and puts. That's what we care about, okay? And the reason we don't touch on the protocols is because the protocols are very extensive. So just give an idea, right? The HTTP protocol standards, right, could be thousands of pages long, because they need to specify every possible scenario that can go wrong and how you recover, right, within HTTP message response pair. Okay. Any questions on that in terms of the key takeaway, right? And what I hope that each one of you can do at the end of the course, right, is to be able to very clearly define what all the features are of all of these layers, and that's the minimum I want you to get out of it, right? But if you can get to the point where you can now understand the interactions between the layers and how to find optimization across the layers, which means what I mean by that is that, okay, I'm at the transport and I'm doing sort of TCP. What are the implications of using a different physical layer standard mean? And how can I perhaps correct for that at the transport? So if you can get that cross-level layer sort of interaction understanding, right, then you're on your way to mastering, right, the details of this particular course, okay, and this field in general. Okay, any questions on the TCP/IP protocol suite? Any questions at all? Anyone? Okay, so we won't touch anything on the OSI model, which is the one that you show on the left, right? Essentially, the reason for that is very simple. The first 4 layers that we care about, right, physical data link, network, transport, they're exactly the same across the 2 models, okay? The OSI model is more of an engineering-driven model, right? And the TCP model is more of a computer science driven model. Effectively, they have now become a hybrid model, which means that they're exactly the same thing. Okay, what happened is that the session and the presentation layers, right, are now all absorbed into the protocols, which is the application, right? So really, we haven't lost anything, but we have simplified sort of the protocol suite from 7 to 5 layers, right? And the course was solely focused on this hybrid model, right, which exists in today's networks, which is being used in today's networks. Okay. Any questions at all?
No, not yet.
Good. Okay, let's move on to the next deck of slides. Can you see that yet? Let me see. Oops. Need to unshare this. I just need to change. I just need to change the slide deck. Can you all see the slide deck?
Yes.
Okay, so I'll move on to module 1. Okay. So this deck of slides is very lightweight, right? There's really no math in it. I want to formalize a lot of things that I've said just now, but also sort of get some the basic terminologies associated with it. Okay, let's start going. Okay, so what is data communications? I said this course is about data communications, right? It's about the communication of information down to single bits, individual bits, I should say, right? Obviously, the communication is going to take place across some distance, which means it is not on the same device on itself. So it could be a client-server architecture, it could be a cloud architecture. It doesn't really matter. Okay, so the idea behind it is very simple, because we do want to share information, right? And that some form of information will be shared across, right, some transmission medium, right, which we'll define in shortly. Okay. Actually, I do have one question, but it's regarding the Wednesday time slot for this class. Was it in case? No, there is. Chantel, where are you seeing that there's a Wednesday time slot? There is no Wednesday time slot for this class. There's simply just a Saturday. Really? I do not believe so. Are you looking at the wrong course? No, there is no Wednesday time slot at all. There is only the Saturday time slot, right? Okay, so it's a 4-hour one-time slot for this class on Saturdays. In your case, I don't see the Wednesday time slot at all. Where do you see that? Edward, can you point me to that? Yeah, there's only Saturday, so there is the morning, and then there's an afternoon, all on Saturdays. Oh, I see. Okay, that's fine. No, it has always been Saturdays, and will always be Saturdays, and will be at the 4. The thing is that both classes are full at capacity, right? So I want you to really just join the sessions that you're registered for. Okay. Okay. Sorry. Okay, let's get back. Okay. So now just to make sure that there's no issues with the calendar, otherwise students are going to the wrong classes. I need to change this. Okay, so let's go back to the deck of slides. Okay, so what I was saying was that obviously, right, then the communication has to happen, right? But there are some components that are required for this communication to happen. Okay. Essentially, we're going to define that there are 5 different components, right? The first of which, right, is that there's going to be somebody initiating the communication. So that we call it the sender. Okay. If you have a sender, right, we're going to have somebody that receives that information, right? And we're going to call that the receiver. So the sender, receiver, or source destination, it doesn't really matter, right? So obviously that data exchange remotely, right, requires two entities to begin with, right? That there is somebody initiating and there's somebody actually receiving it. And the data could be bidirectional. It doesn't really matter, right? But there should be two entities for this remote telecommunication to happen. All of this, right, happens across some form of a transmission medium, right? Which means there is a medium, which in this case, right, for us, right, it's a very complex medium because I'm actually speaking into air, and the air is actually digitizing my voice. The mic is actually digitizing my voice, right, and then sort of goes through some wired networks, go through some wireless, and so on and so on. It's a very, very complex transmission medium that we have right now. But if it was in class setting, right, in an in-person setting, the transmission medium is very simply just air. Right, because I'm speaking into air, and my lungs are compressing the air between you and me, and then your eardrums are picking up sort of the compression of the air between you and me, right, and translating that simply to words. But in any case, right, the communications has the sender receiver across some transmission medium, the transfer of some kind of a message, and the message can be anything. Can be numbers, can be text, can be audio, can be video, can be some kind of complex multimedia. Right? So if you have all of this, can we communicate? Because there is a fifth component, and it shows that we need a protocol. Do we need a protocol? What is a protocol? What do you guys think? Rana,
set of rules to follow to maintain the integrity of the message, or for the message to get to the correct destination?
So yes, so the protocols will address all that. But can we not communicate without a protocol?
It's going to be poor communication because the margin of error is going to be way higher.
Exactly. And Rana's completely right, okay? So I'll say this. In fact, if you only have the four components, right, the sender, the receiver, the medium, and the message, essentially I can communicate. I'll give you an example, okay? I don't speak Russian, okay? Let's assume that I travel to Russia on a trip, and I say, you know what, I'm going to go to Russia, right? And let's assume that I don't speak Russian and they only speak Russian there. Will I be successful in ordering a hamburger? Do you think I can be successful in trying to order a hamburger?
Eventually, it's going to take long time and lots of gestures.
That's right. Exactly. Okay. So I think that I can still achieve my end goal, but it may not be very efficient. So there are two reasons why we have protocols, right? Number one, right, obviously, is for efficiency, right? We want, if you think about it, right, how many packets do you think goes through the networks every day?
I would say trillions.
Yeah, exactly. Imagine, right? Just this session that we have right now, this 4-hour session, right? Over 4 hours could have resulted, right, in tens of thousands of packets being exchanged, right, for the information being brought to you guys. And then I'm going to do that again this afternoon, right? And I'm going to do that every day, right? And everything else that goes on, your Netflix, and there are trillions and trillions of packets being exchanged every day, which means the communication needs to be very efficient. Right? And protocols are one thing to get us there. Okay? Which means that if there's a set of rules that says how message exchange takes place, right? Is there a protocol in this class right now?
Yes. You speak, we listen.
We speak, we listen, that's a protocol.
You speak, you speak, we listen.
Right, but it could be the other way. You speak and I listen too, right? So the protocol allows for bidirectional communication.
Yes.
Right? But think about it, right? The protocol also specifies that the language of instruction in this class is actually English. True? Because if that wasn't the case, right, then this may not be very efficient as well. So the efficiency is one thing to have a protocol, and we will look, into sort of like HTTP is a protocol, right? Why else do you think we need protocols? There's one other reason. One very crucial reasons as to why we need protocols as well. So one is for efficiency. What about, can you think of any other reasons why we might need a protocol? No, not security yet. Security is an afterthought. I'll tell you that in communications. I used to make an argument, and I said that, you know what, security was never really thought of in the early days when sort of the TCP/IP protocol that was created, and I used to think that, and it's truly an afterthought, right? But my argument was that because people were less malicious at that time, and then I very quickly got rebutted by the student and said, oh no, that's not true. right? Humans have been the same throughout mankind. It's just that humans have now found better ways of exploiting, right, the information, because there's more value in data now, and that's why security in data is more of a concern, right? And I agree with that. Okay, so it's not about security, right? The other reason why we have protocols is because we want something known as interoperability. Okay, look at all the laptops you are using now, right? I cannot see any of them, but I'm going to just close my eyes and imagine there are some of you that are on Apple-made computers. There's some of you that are on Lenovo-made computers. There's some of you going to be on Dell, on Compaq, right? And many other brands that you guys sort of purchase and buy. True? Right? I don't believe we standardize on a single manufacturer for the laptops that we use. And then if we go deeper into your laptops, right, do you guys agree that the network adapters are probably also made by different companies? Right? There might be some that are made by Broadcom, there might be some made by 3Coms, right, and so on and so forth, and a multitude of other companies that make the chipsets. Okay, the protocols also allow for something, right? In addition for efficiency, what we call interoperability. If there were no protocols, which means every network adapter manufacturer could build their system to a different set of specifications, and that would undermine the ability for us to interoperate with each other and communicate with each other, right? Because the standards allow, so really everybody adheres to a standard, right? And the standard allows for this efficient interoperability, right, that we actually have. So the system really, right, can operate with just four components. But if we want something that interoperates and have efficiency, then we need the fifth component, which is the protocols. Okay, is that clear?
Yes.
Okay, so this is just a rehash on the components that I talked about. I'm just going to skip over this guy, right? The next thing I want to describe is the notion of how data flows in a network. Right, and I've used this loosely throughout the earlier sort of introductions. Right, I've talked about things to be duplex, right, which means bidirectional communication. But effectively, right, the communication that can happen among the different users, right, have three different flows in terms of data, right? Simplex, half duplex, and full duplex. And in most cases, you have experienced all of these. Number one is simplex. It means that data can flow in one direction only. Right? So in the case, say, of a keyboard, for example, that's a single directional flow of data. Okay? In a sense of sort of your graphics adapter putting an image on the screen, that's a single flow of data. Okay? These days, monitors, at times, most of them have touch screens. That's no longer, obviously, simplex. Okay? But in any case, right, simplex is great when there's only a need for one direction flow of data, like a keyboard, for example. The other benefit of it is that if you start to think about it, if there's only a single direction flow of data, the entire capacity, right, in that flow, right, is dedicated to that direction. Right? So for example, if you're connecting by USB, right, the capacity of a USB 3, for example, at gigabits per second, that entire sort of data flow is only used by that one single flow of direction. But in most cases, especially more in human interaction, we like things to be bidirectional. And there are two ways of achieving that. In the first example is what we call a half duplex mode, which means, yes, there is bidirectional flow of data, but it takes place in one direction, one at a time. Okay, what I mean by that, right, is that one can speak while the one listens, the other one can speak while the other listens. So let's assume there's user 1 and user 2 in this case. When user 1 speaks, user 2 must listen. When user 2 speaks, user 1 must listen. In fact, what you're really doing is that you're time sharing. Okay, and that's what we call a half duplex mode. Oops. The benefits of it, I should ask if you have examples. Walkie-talkies, anybody use a walkie-talkie ever? Or anybody has experienced sort of a chat session through a walkie-talkie type of a setup, right? It's very simple. It's basically one person talks at any one time, because every time you talk, you have to depress a certain button, right, to allow you to have that communication going on. Okay? The nice thing about such a half duplex model is that it is bidirectional, right? Yet at the same time, you're allocating the full capacity to each direction of data flow. So you don't have to share them. Okay? And if you allocate the time slots in a way that is insensitive to the human, let's talk about human application, then in fact it's almost simultaneous, but you get the full capacity. As opposed to the second mode of sort of data flow, right, where we have what was called full duplex, where data now can flow in both directions simultaneously. Right? So if I'm talking and Rana starts talking, right, that's two flows of direction, right, in terms of data, right? It's a full duplex mode. But in this particular case, right, what happens is that the capacity now needs to be divided, right, between the two directions of flow. Does everybody get the difference? Note that this capacity that's divided does not have to be 50-50. It could be 80-20, it could be 90-10, it could be 60-40. It doesn't really matter. But all I'm saying is this: yes, we can attain a simultaneous bidirectional data, right? As in sort of like a phone conversation, or in this sort of voice over IP session that we have right now, right? But obviously, right, we have to, right, divide the capacity between the two directions. Okay, is that clear?
Yes.
Any questions on that? Okay, let's see. Okay, good. Okay. So then the third thing that I want to talk about, and it's probably the last thing that I will sort of end on today, right, is that I want you to understand the notion of what a network is. Okay. A network, as we will study, right, is simply nothing but having a set of devices that are capable of communication. So we don't care what it is really. We care about really just the data communication side of things, which means the data flow. Okay, you could be using a laptop, you could be using a tablet, you could be using a smartphone. It doesn't really matter what the end device is. In fact, we don't care, right, whether you're using a router or a switch, right, as an intermediary sort of a connection point, right? The whole idea is, from our perspective, is that there is data flowing from source to destination across multiple of all of these devices, right, that enables that to happen. Okay. From a network perspective, right, and I want you to sort of put yourself in the shoes of a service provider. So most of the times, right, when I ask you, what do you want as an end user when you sign up for an internet service? I mean, what are your criteria when choosing whether you want to use Shaw as your service provider or Bell as your service provider or TELUS? How do you choose that?
Reliability. So it's not going to break. Yep.
Yeah.
Not going to cut off on a sensitive time.
Sure. Okay. What else?
Fast enough.
Fast enough, right? Okay. So what else? What else? Anyone? Pricing, unlimited data. Exactly. Okay. To the end users, right? Really, right? Pricing is usually one of the greatest concerns, right? And then the next thing that you care about is the throughput, which is obviously data, right? Whether it's unlimited, but you not just unlimited data, but you want the high-speed data, right? Sort of what William has said, right? And you want very low latency. But I want to also put you in the context, right, of a service provider. So when we look at data communications, right, from a network perspective, we're not talking about the user experience, right? Obviously, that matters. But from a service provider point of view, right, there are three things that we really want to be sort of concerned about. Number one, obviously, is performance, right? Because network providers know that users want high throughput and low latency, right? Obviously, they will evaluate their networks based on that. But more importantly, for sort of your network providers, right, is there's a notion of reliability. And sometimes you'll hear this as uptime. Has anybody heard of 5 nines as uptime, 4 nines, 3 nines, right? So if a network, right, yes, yeah, performance is the upload and download speeds. So that's your throughput. That's your bits per second that you transmit over a network, okay? But the thing that I want to bring is, right, the uptime of 99.999, right, 5 nines versus 99.999 versus 99.9. Yes, throughput or data rate. Okay, and we'll be more and more precise with the definitions as we go along. They're all measured in bits per second. Bits per second, but the context that they're used in is not exactly the same. Okay, Edward, and we'll unravel that. In essence, right, the data rate, right, is the data rate that you can achieve. The throughput is what you actually use. Okay, but more importantly, right, as I said, is that the reliability is how often do you fail, right? And most networks, tier 1 networks, have what is known as a 9% uptime, which means that you are only down less than single-digit minutes per year, right? Your tier 1 providers will usually have an uptime, right, or close to 5 nines. Your tier 2 or tier 3 providers, right, may have up to 3 nines. Okay, but more importantly, too, right, from a reliability point of view, is that yes, we know that the networks, however much of redundancy you build into it, may always come to and suffer some kind of a catastrophic failure, which means networks go down. Okay, how you recover from it is also just as important. Okay, and how robust you are, which means how resilient you are, right, to being failed. Okay, so those are the additional things that if you now start to put yourself in the shoes of a network service provider, right, you need to be concerned about that. Okay, and then the third thing, obviously, right, is security that Yongjun keep bringing it up, right? Security from an end user perspective is very much simply like username, password, but that's not what the service providers care about. Right, your username password is really very much used in security terms as an authentication means, which means you're identifying who you are, right, and verifying that you are indeed who you are. Okay, what providers care about, right, is how do you protect the network from hackers, right? How do you protect the networks, right, from sort of hacking and sort of manipulating the data? Okay, so that's the first thing, right? So we talk about, very classic network breaches that have happened along the time, right? This is extremely important. Okay, that you are aware that in fact, right, networks can go up and down, networks can actually get hacked, right? But more importantly as well, right, is that you need to be aware if when a network goes down because of security breach, how do you recover from that? How do you assess the damage, right? So that's so this is security beyond just encryption, authentication, right? This is about a network as a whole on how do you even detect intrusion into a network, right? And security courses will cover things like firewalls, the logs, right? Sort of deep packet inspections, and in fact, machine learning is now applied, right, a lot into sort of all of these security firewalls, right, to predict the possibility of an intrusion. Okay, so I want to give you a very high-level overview of what network criteria are, because I want you to move away from the context, right, of what you see as sort of a end user. Okay. So this is as much as I want to sort of cover for today in terms of the lecture, because I have one other thing that I want to share with you today, right? So next week we'll continue on with 1.3, right? And the thing I want to share with you is this. I'll show you now. Okay. Remember I said that every week there is a quiz. Okay. So there's no quiz for you today, but I want you to sort of get an experience with it. Okay. Oops. How do I cancel this? Okay. So if I share my browser, one sec, I'm just loading it up here. I just lost that screen here. Can you guys see the screen share at all?
No.
Oh.
Still seeing the whiteboard here.
Yeah. There you go. Okay. Do you see this now?
Yes.
Okay. So So basically what will happen is that you every week you're going to do a quiz and expectation of that, right? So today we're not doing that at all, right? But I want to give you an idea, and I want you guys to give me some feedback as to, let's assume that we have a quiz, right? So this rules will remain the same every week, right? You basically will get something. How I intend to run it, right? Because it's difficult for me to actually run a quiz for this course on D2L because it's mathematically based and I need to sort of look at your work. What I was thinking of, right, was to be able to flash the labs, right? So if I do it now, and I pull up this document, okay, and say, okay, let's run the quiz, right? And effectively, my thoughts of it are this, okay? I'm going to share with you what the potential sort of quiz questions will be today, okay? So let's assume that I run onto this. Oh, this is not the right one. Sorry, let me just get the right one on here. Because I'm thinking that this could be a potential way of running the quiz. Yeah, go ahead.
Sorry for interruption, but just a question. So you're going to show us the questions on the share screen? You're not going to upload them?
Yeah, because if I upload it, so I'll leave it on the share screen, and I'll tell you that every question is time boxed. Okay, and I'll talk about the alternatives. So we'll take a look at this and see if it works. This is one thought I have on how we actually can run the quiz, but this is not the only way that I will do it, right? But I just want you guys to experience it for a second here. Okay, Rana?
Yes.
Okay, so I could say, okay, well, let's get the quiz started, right? This is the first question you guys will work on.
Could you zoom in, please? Could you?
Oh, yeah. Okay. So see, those are the things I want to sort of iron out as well, right?
Yeah,
so
that's why I was asking, yeah, because when you showed us the first time, it wasn't really clear. It's difficult to read.
Yeah, no problem. Yeah, okay, I can do that too. So see, this is the things that I want to home. Yeah, I see. So it may have to so every question will something look like this, right? So I cross out the marks, the time allocated. So basically, it will be a time boxed every question, right? You guys will say, okay, you're given 8 minutes now, solve this problem, right? And the idea is that you take out a piece of paper. Don't worry, I'm going to upload this particular one online so that you guys will see the questions later. But I just want to run through the process with you, okay? And you can give me some feedback whether or not this will actually work. Okay, so I'm going to flash the question on the screen and I'll say, okay, there is this question that you guys have to solve, right? It's worth 5 marks and you have 8 minutes to do it, right? This particular question really does not require any datacom sort of knowledge to do it. It's really multiplying a few numbers to decide how many bits that you need to do, okay? And then you do it, and then I'm going to say, okay, let's move on. Time is up, 8 minutes. Let's move on to the next question. Right, I have to find the next question, and then obviously the next time I'll do is I'll blow this up really, really, really large. Right, supposedly that there's one question that says, okay, I want you to solve a log question. Right, what is log 9, 9 to the power 9, for example. Right, what is log 2 of 4096, and so on and so forth. Right, and I'll say, okay, you have question 2 worth 4 marks here, right, and you have 8 minutes. Okay, and then there's a third question for this one, but that's just for the sake of it, right? Is that if we do this, right, then I blow this up again, right? And then I'll say, okay, let's solve this, right? And then do it in, I'm wondering if landscape would be better. Yeah, landscape might actually be better, right?
Yeah, I agree.
Yeah, so I'll do those changes to it, right? And I say, okay, well, go solve these problems, right? So this is not a quiz. This was never intended to be a quiz. I don't expect you to know this right now. This is just an example of what the quizzes might be based on sort of how it will be administered. I say, okay, now you have this guy, you know what? Go solve it. You have 10 minutes to solve these questions, and then obviously I'll have a timer running on my side, right? And then when you're all done, then I'm going to say, okay, now what you need to do is you need to upload your solutions to it. Right, so oops, sorry. If I go with this, and I can just say, I know. So I will discuss that. Like so certain students have accommodations that allows them to go on, right? with additional time? Yes. So I will talk about IAPs later individually, right? Because that's a very that's very few that are impacted by IAPs. Okay, Lacey. Okay, I'll think about how that can be done. In class, if it's on paper, usually students with additional time can write longer, right? So I will allow for that, right? It's just I need to figure out how administratively we can be done online. Okay, so the only thing I see that is that sometimes we can go back to easier, everyone's different, and go back to us, and then we can, yeah, okay. So I've thought about that too. So Shankai, right, is that you guys like to jump between questions, okay? But most quizzes that you'll get actually only consists of one question, at most two. So this is a different one. This is because I want to just give you guys a math review. So this is not indicative of the type of questions you get, but in most cases, in most quizzes, you're only actually going to get one question, and you're going to be given up 10 minutes or 15 minutes to do the quiz. The quiz is never the quiz is really just a pacer for you that you understand. Okay, based on last week's material, did I understand this? So the quiz might all just be this, right? Okay, there are two questions. Solve these two law problems in your 15 minutes, and I'll show you both the problems. Does that make sense? But what I'm suggesting and showing you now is running through sort of a dry run of the process of doing this, right? Is that, are you guys okay with sort of running the quiz this way? Because I can talk about the alternative.
What's the alternative?
Yeah, maybe let's do the alternative. The alternative is actually, I'm not in very big favor of that, actually. It's requiring that all of you install this tool called Proctorio. Oh. Okay. The Proctorio tool was brought to us 2 weeks before the end of the term, last term, as a possible way of administering remote exams. Effectively, it's a software installed on your computer that makes use that makes use of the webcam and the microphone and potentially a second camera in your room. And it's monitoring you when you're writing the quiz and capturing images and your voice.
Well, I guess, yeah, the vote is unanimous from what I'm seeing.
Right. So, and I'll tell you why, and I completely understand from a student's perspective, because there's an intrusion of privacy there. Right? And BCIT at this point in time has not provided us with any other better means, right? Which is why I'm personally not that big of a fan of using Proctorio. It's actually easier for me if I actually use Proctorio, but I think that many students will be very uncomfortable using that tool. So my other alternative is this: is that I cannot really upload this quiz ahead of time. I have to do it in real time. Otherwise, then the questions are known and it's no longer a quiz, right? Because you're going to be assessed for this. So my goal is that I'd like to be able to flash this in the quiz, and then you guys are given a set amount of time to do it. Can you elaborate on that, Chantel? Right, but it's not just that though. So I need to. So the reason I have to time box it, right, is very simple. Okay, I need to ensure that this is done in real time, because my thing with all of these individual assessment is very simple. If I cannot have a certain level of confidence that there is no compromising of the integrity of the assessment, then the assessment is unfair for all students. Okay, so the reason I want to time box it in real time is so that, you're right. In any case, my hope is that everybody will hold the highest level of ethics. Right, uphold the highest level of ethics, right, and be the one actually writing and submitting the quizzes. And this is one of the opinions that I have, is that if I can flash this across, right. No, but it's not that I don't. No. So I want it to be done in real time, so that you're not going back and forth and you're not sharing the questions. There's no way for you to be on Discord and all that stuff, because I'm not monitoring you remotely. So you only get the questions for the moment that you need it.
So you have no time maybe to privately chat with someone, or to get the answer from somewhere, or to Google it, or something like that.
Exactly. Right. This is what I'm trying to attain here. Right. And I'll tell you how I actually came up with this idea. This idea is effectively how my PhD exams are held. I would go to room to meet with different professors. And essentially, when I enter the room, they'll ask me a question, and I have 15 minutes to solve it on the board. And then when I'm done with one professor, I move on to the next room. They'll give me another question. I have 15 minutes to solve it on the board. Okay, this is by no means perfect. Okay, I want you guys to sort of think about it. I want to just give you a dry run to show you how the quizzes will be run. And feel free to email me if you think of a better mechanism and if you feel that there's tremendous downsides to this, right? Right now, my other alternative that I have, right, is really Proctorio, because that's actually a tool that BCIT endorsed. But I'm very aware of the privacy concerns associated with that because it's almost like installing a spyware on your computer.
My issue is with the 4 minutes to submit answers. So, for example, if you have a scanner and the scanner suddenly didn't work or something like that,
Right,
and you're mandating it to be PDF, so you have to actually get it to your device somehow and convert it before submitting, and that requires time.
Okay. So maybe in the quiz it doesn't have to be a PDF. Maybe in the quiz it can be a JPEG, right? Because JPEG requires you to snap a picture,
exactly, and
upload it.
Attach it and email it.
Yeah, exactly. So okay, so in a quiz I would say it doesn't have to be a PDF. It could be just a JPEG, right? But you guys can think about it. The preferred mechanism is PDF because I want a uniform sort of thing. But
Format.
I'm open to. Yeah, exactly. But I'm fine with it being a JPEG as well. I don't have an issue with that. I'm more concerned about, is this an okay forum to administer such questions?
Can we have a practice exam before a practice quiz before the real one, just so we can have a real-time experience, just to give feedback or something like that, maybe by next week or something?
Yeah, I'm all for that. So in fact, next quiz is not for marks, but it will be a quiz. It just won't be for marks. You will do the best you can. Okay, that's my intent. But I wanted to show you this. So I'm going to upload this one. I still want you guys, so we have the 4-minute leeway to hand in the quiz. Yeah. 4 minutes. Is that too short?
Considering my son had issues with the scanner when he actually scanned his final exam, I would say definitely yes.
Okay, so what do I say this, right? For all quizzes is essentially just a JPEG. I said PDF actually because there's many sort of no. Every question, so you'll see this, right? Every question has an allocated time. So this question will give you 8 minutes, right? This is 8 minutes for this question. Then we move on to the next question, and then you see, okay, to solve this, you have 8 minutes, right? And then to solve this, right, you have 10 minutes. Okay. Then the moment so the moment this thing ends, right? Then I will set the Dropbox to close in 4 minutes time. So if it's 1:01 now, it will close in 1:05. Okay, so does that make sense?
It does. Again, the only way for us to find out for sure is to try it out, to have a real-time experience.
Exactly. Okay, so let's do that trial next week. Okay, in real time, meaning that you will actually be told to write a quiz, right? And then let's just see it. Okay, and then for those with IAP, please send me an email. Okay, the students with an IAP with extended time for quizzes, exams, and so on and so forth, can you please send me an email and then I'll respond to you privately as to how we can actually extend the time for those individual students that are impacted. Oh, you can do both, Iris. My thought was that if you guys can write on a tablet, it usually can export it directly as a PDF, and then you just upload the PDF. But I'm aware that not everybody has a writable digitizer. So if you write on paper and then scan a picture of it, right, either as a JPEG or PDF, that will work as well. Sure, I will do that. Okay, I'm going to do that soon, Yongjin. What portion? The beginning of class. Usually within the first hour. So usually what I do is I come in next class, I take some questions, do some review, and then we will do the quiz. Okay, but next week's Next week's quiz is a mock quiz. Okay, so I'm basically done with the with session today. For those of you that want to log off, right? Please do so. So I asked for two things. I'm going to be, you know what? Let me just do it now so you can see it in real time. Okay, so I'm gonna now go back to this. Right, I'm gonna upload the actual material for this week application. Where's my browser? Okay, so. Right, guys, do you see my browser? Okay, so now I'm going to go to sort of the quiz. I'm going to add the new file, which is in this case, I'm going to now do page 2 of the quiz. Oops. Okay, does everybody see the question now? Right, so
yes.
if you click on it, you'll see the questions. Okay, then what I'll do, Yongjin, right, is that I'm going to now, so this is the quiz, you should be able to see it, right? This is the problem you should be working on. Right, maybe I forgot to say this, but I also uploaded a math review for you in the study material. Right, you should take a look at this to do the exercise today. Okay, and then what I'll do, Yongjin, is that I'm going to now go and enable this quiz. Right, and then I'll make this quiz folder visible to the users. Okay, and then it will have a deadline for you for beginning of the class next week. So it won't be this time. I'll change the due date. So it will be, you have 1 week to work on it. Is that okay, Yongjin? Okay, so then you guys can trial it. But next week's quiz, again, it will be a quiz, right? But it will not be for marks. So you'll not be assessed on that, because all I want to do is just sort of run through the process and make sure that you guys are still doing the quiz. But at the same time, right, because you're impacted by technology, right, it will not impact you. Okay?
Question. Yeah. The study sheet, the numerical prefix logarithm sheet, should we memorize it, or can we have it handy?
No. You can have it handy all the time. Don't worry about that. But you should
you should memorize eventually. Yes, I understand.
Exactly. Yeah, with practice, it should come to you naturally. I should say that. Yes. You shouldn't have to memorize it. It should be part of you. But I want to just get everybody up on the same par. I can review this. I forgot to review that today, but I can go through this with you guys next week as well if necessary. Right, it's basically COM 1113 in terms of base manipulation, some notation, and then obviously just simple logs just to get you started. Okay. Yeah. Any other questions at all? So think about it. So a couple of things that you need to do. If you have accommodations, please send me a private email, and then I'll reply to you separately. Okay. If you have any comments or concerns about how we run the quiz, also send that to me by email, and I'll try to perfect sort of the. Will never be perfect. I'll try to make the experience better for everyone. Okay. I think right away JPEG is probably the better format to submit, because you can snap a picture without having to do conversions. But for assignments, I'm going to ask for a JPEG because you have a lot more time to do that. Okay.
Is it possible for you to maybe upload some exercises or practicing material?
For what though?
Especially for the math sheet, for the numerical prefix logarithm sheet?
No,
or can we just Google stuff and
exactly
practice?
Because that's, to me, it's a refresher. So I want you to sort of do the exercise first, and then assess how far you are. If you can solve it very easily, then you're well prepared. If you're having tremendous difficulty, right, then you need to put in a little bit more effort.
Okay.
Yes, PDF for assignments. But I think I'll change it and say JPEG for quizzes, if that's easier, or JPEG and PDF for quizzes. Right, but for assignments will be PDF, because it's the PDF files are a lot easier to manage for the marker. Okay, so I'm going to end the class here, but I'll stay online for a few more minutes. What I want to do is I know I'm past time. I don't want you guys to be held any longer. So if you have no other questions, you may exit the Bongo session. Okay. If you have any other questions, email me. If you have any concerns, any questions, email me. Okay. And I'm going to stay behind for a few more minutes and then take additional questions if there are. Okay, so please work. Yep, see you all next week, right? Thank you, everybody. Hopefully, the session becomes... the next week's session will be very different, because this first session is always one where it's filled with a lot of information. Okay, thank you, everybody, right? Please have a great week, right? Enjoy the sound when it comes out next week, and I'll see you all next Saturday. Thank you, everybody. Yeah, I'm very surprised that everybody doesn't want Proctorio. Okay, as I said, I'll remain online for a few more minutes if you have any questions, but otherwise feel free to sort of log off so that I'm not holding on to everybody else's time.